sent you an email. So I always forget. Yeah, I gotta make sure there are. Yeah,
Tracy would be here, Dan.
she's on her way.
Can't listen to I didn't value punctuality. That's all I'm saying.
I hear you.
Text her that. She's gonna come home. That's what I'm gonna do.
Sorry, my hands are so
Scott said we still going to try to get
Just got the.
Like I was just here. Yeah. Reappropriate. Down. Yeah. My wife. Well, basically, 2 days a week, so I can there. And Talk about that.
Check, check, check. Hello, everybody. Can you guys hear me in the back? Good. All right. Thank you. So I think let's please be seated and let's get started here. So, see. Wait for it. Let's close the door and then we can get started. Okay. Good morning, everybody. Thank you. And I am Emily Long from NASA Jet Propulsion Laboratory, and I have the pleasure to be the president of the Earth Science Information Partner ESIP, and it's a great pleasure to be here to welcome you and thank you for coming to the 2017 ESIP Winter Meeting. So I'm very happy to see a lot of friends, friendly faces here that I know for a long time, and also we like to see a lot of new faces here that some of the first time attendees. I'm looking forward to meeting you and getting to know you better. So what a wonderful way to get together for us to reflect on all the accomplishments this community has achieved in the past year, and also get together to welcome the new year. So this year's overarching theme for the ESIP is strengthening ties between observations and user communities. It is based on one of the goals that set forth in our 2015 to 2020 ESIP strategic plan that provides guidance and also set a framework for all the ESIP work to be done over the 3 years. And throughout this meeting, the theme is going to be embedded and also integrated into all the work that we are going to be doing in the collaborative areas, cluster, working groups, and also committees, and also in public outreach, community outreach, and also in working with our national and also international partners. The goal is really to improve and also increase the dialogue between the earth science data providers, data distributors, and also the end users. So all the planning talks that we have, poster sessions, and breakout sessions, poster presentations, and also panel discussions, as well as the meetings, networking opportunities throughout these few days at this meeting, is going to be a great opportunity that will allow us to deep dive into the conversations. So those ought to be really stimulating, and I hope you will enjoy them. Take the opportunity to get to meet new people, make friends, make connections, and give a warm welcome to all the people that you don't know. First time that who attend these meetings. I'm sure that we as family, we can make more friends and make everybody welcome to be here. Also, don't forget that the networking opportunity also online. So use Twitter. You're able to start a conversation, join a conversation, follow a conversation that way as well. So before I hand it over to our Executive Director, Erin Robinson, I would like to first, start with a few acknowledgements. So first of all, we want to thank our sponsors, NASA, NOAA, and also USGS for sponsoring the ESIP community. It's their generous funding that keeping the ESIP light on. And so I would like to thank Element 84, and they are sponsoring the lanyards for this meeting, this beautiful lanyard we all are wearing today. So at this time, I would like to invite the co-founder of Element 84, Dan Colon, to come up here to give you a few words about Element 84.
Thanks, I'll be real quick. So I'm Dan Colon, co-founder of Element 84. My wife is the other half and stuck in traffic, so I got to step in for her today. But we've had the privilege of really working with a lot of you in the ESIP community for a number of years now. And if you don't know us, we're a small software development company based out of Old Town, Alexandria, specializing in scalable earth science systems. We've been able to be a part of ESIP for a while now, and recently had the opportunity to lend support to the great work Emily and Erin, Bruce, and Annie, or everybody else in part of the ESIP community that are doing this. And so we wanted to take advantage of it and do what we could to help the meetings and everything else that we've had a chance to be a part of. So thank you, and
I would also like to extend my appreciation to the visionaries. That working group led by Steve Hicks, he's at the back somewhere over there, and Denise Hills. They play a key role really in the planning and also development of this meeting. And in addition, we cannot not thank our stellar team of ESIP staff. Dan Keys over there, Andy Keys, that she was at the registrations. Ruth, I don't know where he's sitting right now, somewhere over in the front here. And Annie Burgess, she's not with us because we turned to. And their fearless leaders, our executive director, Erin Robinson here. It's really their hard work and all the details they put in this meeting, that we have wonderful meetings like this. And lastly, my greatest, gratitude to you all is really your presence, your support, and your continuous contribution to this wonderful ESIP community that allow us to have great meetings like this. So enjoy the meetings, and at this time I will turn it over to Erin for some more logistics.
Thank you so much, Emily, for getting us started, and thank you all for being here. So just to give you a little idea of who's here, I wanted to start with this slide about the ESIP community because I think it's a special composition of people that end up at these meetings. So they're coming together, you're all coming together across sector, so academic, industry, and government, and across the data lifecycle, from the data providers and the observation community to the user community and the tool developers. And so I think that what we find when we bring all of you together is that there are these common problems that come out. And yesterday at the NOAA Environmental Data Management Workshop, somebody described this as undifferentiated heavy lifting. I think those are the problems that ESIP starts to solve when all of you come together. So I think that this is a good meeting. I wanted to welcome our new members. We have 4 that were just brought in this class. Iris, I saw him walk in. SSAI, the Gulf of Mexico Coastal Ocean Observing System, and the Department of Energy, Climate and Environmental Science Division. And I didn't see Jay this morning, but I think many of them are going to be here this week. I also wanted to welcome our student fellows. Student fellows, can you stand up? So we have 7 this year. They're going to be around. They'll be in the sessions. Look for them. We're very excited to have them. And, so that's another great addition to our meeting. Thanks. then as Emily mentioned, me and Kurt just had a baby in December. This is Woody, and we just wanted to wish her all good luck. She'll be back in March, and we miss her, but we really like getting these cute baby pictures. And also there'll be a card at the registration desk. So we had a temporary registration desk set up this morning just so that it would be quick to get badges and breakfast. But the permanent registration desk is at the bottom of the escalators, and there we'll have a card for Annie if you want to stop by and sign it if you know her and you're so inclined. So this is a little bit of an at a glance for our week. You'll notice that we don't have paper copies of much of anything of the schedule this time. We're really moving towards the end, which I'll talk a little more about. But this morning we're in Plenary. We'll have breakout sessions this afternoon and the poster session and networking this evening. It will be up in this hall. And then tomorrow we'll have the assembly meeting, and we keep trying to move around the state of the Federation to see where it makes the most sense. We're trying it in a new place with the assembly meeting. So I'd encourage you, if you're interested in the overall activities of ESIP and really want to know about the details of the committees and the things that are happening in the ESIP community, hear from our sponsors, that you attend that meeting even if you wouldn't normally attend the assembly meeting. And then we'll have a plenary on science leadership moving forward, which should be great. And then we're back to breakouts for the rest of the meeting. So it's really mostly a working meeting. There's a lot of things going on, as you all know, you've all contributed. And so I hope that it doesn't feel like too much plenary. So getting to the meeting tools, does everybody know about Sketch? So I should have added the link here, but it's 2017 ESIP winter meeting, sketch.com. And this is where you'll find all the details of all the sessions. Basically up to date from everything that was happening up to yesterday, maybe. You can check the sessions that you want to attend, and it'll send you a reminder email in the morning the day of. And then there are a few things on this sketch page. There's a link to the Commons where we'll have all the slides. There's a check-in link, which I'll get to in a minute, and then the remote participation. And I have to give a huge shout out to Dan Keys, because as you all know, we really struggled with remote meeting and having the audio sound like, and he's finally figured out how to get the house audio in all of the rooms into the computer, and so we should be able to hear people both on the far side, and they can hear everything as long as we remember to use the mics. So it's a huge deal. This is a reminder to add things to the Commons. I will say, and we'll talk more about this as the meeting goes on, but we're struggling with the Commons, and we're hoping to find a more streamlined way to have meeting content moving forward. Now to talk about I'm Here, this is something that I think many of you who've been to an ESIP meeting in the last year or so are familiar with. imhere.esipfed.org. And if you go to the check-in, then you can add your name and your email. And if you already added an OpenAQ ID to your registration, that's pulled in. So that'll take you to a page like this. You can have a public check-in or a private check-in if you don't want to show up on the list. And then the sessions, and I was pulling these screenshots before we had everything running, but there should be, the welcome is running right now, and you can see who's in the room. They've publicly checked in. And then this is what the profile looks like, and we're pulling from the Orchid, or the link to the profile is to the Orchid profile. So update your profile once with Orchid, and it shows up here too. And then I want to come back to what Emily talked about. A lot of times ESIP can seem chaotic to newcomers, and we do have some threads that tie us together. And so we have a strategic plan, and I think one of the unique things that we're trying with the strategic plan is, instead of forgetting about it, focusing each year on one of these themes. And so this year we're focusing on the second goal of strengthening the ties between the observation and the user community. And we're doing that in a bunch of different ways. We'll talk about it a little, the disaster life cycle work that we're doing a little later in this plenary. But I think that it's a way to think about, this is one thing, and what are you doing that might be supporting the theme? So, how we all orient around a shared agenda. And then, to reiterate what Emily said about, being open to talking to new people. And one of the great things about ESIP is we've increased the network density. And so there's a high likelihood that you'll turn around in the coffee break line and, you know, somebody will your same metadata problem or your same semantic web problem or understand what you're talking about. And so I would encourage you to embody these values of ESIP too. And with that, I want to turn it over to Christine White to introduce our first plenary speaker, Amber Case.
Good morning. I have the honor of introducing our first presenter, Amber Case. Amber studies the interaction between humans and computers, the influence information has on cultures and how we think, act, and understand our world. She's one of our young, innovative minds of our generation, pioneering things like CALM technologies, C-A-L-M, CALM, and has written a book about it. CALM technology designed for next generation devices. So very interesting idea about how that interacts too with some of the work we do. She has been an author and speaker all over the world. Was the keynote in the South by Southwest 2000 gathering. Her TED Talk, We Are All Cyborgs Now, has been viewed over 1 million times, well over 1 million times. And it's really great, so if you haven't seen it, you should watch it. She's a National Geographic Emerging Explorer, Inc. Magazine's 30 Under 30, one of Fast Company's influential women in technology. She co-founded a company that Esri bought years ago, and now she continues to do her research in the intersection of the future of technology, humans, machine learning, and anthropology, and how technology can be a tool for humans and in an anthropologic way. So she has a lot to say to us, and she'll be here all day. So if you see her, and Amber, maybe you go ahead and come up so people can, well, they'll see you because you're going to be talking next. But if you see Amber, she's here all day. Please pick her brain. She will definitely pick yours. And I'm very honored and excited to hear what she has to say. Thank you.
It's fantastic to be here. It makes me miss working at Esri a lot. So I'd like to talk with you about CALM technology. First, who has seen this statistic? Has anyone seen this? Okay, so a few of you have. The idea is that there's going to be lots of devices. We're already dealing with an overwhelming amount of information from all of these devices. And whenever I see quotes like this, that there's going to be all of these devices in the future, I ask whether this actually sounds good or not. Oftentimes futurists say that at some point in the future, everything will be figured out and won't have any problems anymore because of technology. But as all of you know, the more technology we get, oftentimes we get more edge cases and more issues. It's not that everything is consistently solved, it's that things get mildly better and we take a few steps back in the process. So I like to consider whether that actually sounds good. Is it really a great thing to have 50 billion devices in the future? Can we consider ways in which that might go right or wrong? For instance, the smartwatch, when that first came out, the notifications were the default of what you would receive on your phone. It wasn't tuned for what you might want to receive on your watch, or whether you'd actually like to receive anything on your watch other than the date and time. Or the idea that I've seen from a lot of companies of this kind of smart fridge. The idea is that the smart fridge would lock if you had eaten too many calories, in which case, yeah, you might have a smart fridge, but you don't have smart cupboards, just to keep you from going into the snacks in the cupboard. This doesn't make any sense. Or the idea that it would beep at you to tell you that you need more eggs and milk at the store. Who doesn't buy eggs and milk when you go to the store? This isn't something that you need some smart device to tell you. Or even this connected egg carton that will tell you when you're running out of eggs, as if I couldn't just go into the fridge and look and see if there are any eggs left. Like the idea that in some completely random situation, I might be told that the eggs are running out, like when I'm in a meeting, and suddenly I'm giving a presentation and it pops up, you need to buy more eggs. Like, when you put all these things together, especially with different groups and teams, publicly and privately traded companies, people that are doing startups and people that are running on legacy technologies, you get what I like to call the dystopian kitchen of the future. This is kind of a really annoying version of a family circus comic in which everything, including all of the kids, is yelling at you, vying for your attention at the exact same time, telling you that there are security alerts and freakouts and that you need to update almost every single thing to work together. That you shouldn't put that connected tea kettle too close to your connected stove because there might be some issue with that. Not to mention that you're trying to Netflix stream something and the amount of bandwidth that your IoT devices are taking up is higher than the amount that it costs to actually stream that video. So you actually get all these buffering issues. My favorite thing though, actually not favorite, it's kind of dystopian, but I kind of like dystopian scenarios, as you can probably determine from this point. There's this company called PetNet. If any of you have pets, you understand that sometimes you need to leave home and you want to leave them remotely. So PetNet said, all you have to do is connect this to your internet, and then you can not only visit your pets through a kind of pet Skype through our app and make sure to keep them company, but it will feed them on regular intervals. Can you imagine how this might go wrong? I call this the new Schrodinger's cat. You know that your cat exists within the box of your house, but you don't know whether it's alive or not. So of course, PetNet lost their servers, went down, and they didn't know how long the servers would go down. And during that time, their customers trusted the technology. They didn't have any backup systems in place. And so their pets were kind of stuck in the house. People were flying home from trips and trying to get into their house to feed their pets. And they also didn't know whether the pets were being fed or not. And the code that was supposed to back up, basically, if there's no network connection, still feed your pet on these regular intervals, that hadn't been really finished yet. So the whole point is there should be a backup system here, a backup system. And then if you look in the terms of services, so all these people, they didn't know whether the cats were alive or dead or the dogs were alive or dead. So of course I went into the terms of service and I said, okay, who's responsible for this, right? Because if this is a human's life we're talking about, not to mention pets, which are increasingly being considered as exciting as humans these days, but the idea is that somebody should be responsible. So I went through these terms of service, and PetNet's not responsible for any of these service failures. So then the question is, shouldn't we have a giant warning sticker on the box that says, hey, this is supposed to be a feeder that you can trust with technology that you can trust with this new Internet of Things, yet it might fail at any time and we're not responsible if your cat dies. So I got really mad at this. And I started to think of a few other situations in which there were all those webcams that people had in their houses, and those webcams seemed really great, except people kept leaving the passwords as the default 1, 2, 3, 4, 5, 6. And so for a while, security researchers said, let's just make a website that shows how unsecure these webcams are, just as kind of a warning, so that the industry can kind of understand that we need to not have these default passwords. And so at the hackerspace that I'm part of in Portland, Oregon, we would go to this website and we'd see all these unsecured webcams. And we try to tell people, like in some cases, you can actually talk to people through the webcams. So you'd be like, hey, your webcam is unsecure. And then they'd be like, eek, that's terrifying. Reset your default Wi-Fi password. Oh no, my camera is talking to me. So now that company that provided those Wi-Fi connected cameras is actually getting sued by the FTC, which I'm glad about, because the issue is that you have something that there's a promise to consumers, yet you don't have them reset these passwords, and then you pass on the risk to them. So of course, as you all know, there was this giant attack, the largest DDoS attack in history, where all this data was sent over, and everybody's little Internet of Things devices contributed to this overwhelming sense of just traffic clogging. And it wasn't supposed to be one of those attacks where it tried to harm anybody. I imagine it was a bunch of security researchers that said, okay, we're going to have a larger and larger attack until somebody actually cares. And then they took out the DNS layer on like half of the United States internet, which is just, you can still use all the websites, you just have to type in the IP addresses. Not that everybody's memorized IP addresses or anything like that, but it didn't really take anything down. It just looked like the internet was taken down. We have this era of interruptive technology, and the opposite of that, as I discovered, is this concept called calm technology. And calm technology is the idea that you should be able to get information in your life without being interrupted constantly. It makes use of your peripheral attention instead of your primary attention right in front of you. And it allows you to make decisions and be more human instead of being less human because of all these interruptions that happen all the time. So where did this concept come from? When I was doing my thesis, I found this, this concept from Mark Weiser and John C. Brown at Xerox PARC. They said, look, we're going to create this web of all these things. Mark Weiser is considered the father of ubiquitous communication, kind of now known as IoT. And they said, well, we'll connect all these things together, and we'll have these little active park badges that you can wear around your neck, and then when you get into the office in the morning, it'll automatically connect to your computer in the background, because your computer takes like 15 minutes to boot up because it's the 80s and 90s. You know, by the time you get your coffee, you get to your terminal, and the computer's booted up. Let's do all this fun stuff with technology. But what they realized after installing all of these things over the local network is that the scarcest resource was their attention, wasn't the technology. And they said in the future, we'll have way more devices than people. And that's when that attention becomes the most important thing. How do we make technology that respects our attention instead of getting in the way and not letting us live our life? So they have a bunch of different papers. One of them is called The Coming Age of Calm Technology, which I really enjoy. These are all up on calmtech.com. I kind of tried to resurrect some of these papers and make them readable and accessible. But the other is called The World is Not a Desktop, which is just a fantastic name because a lot of people keep building technology that requires the same amount of attention as we would if we're sitting in front of a desktop computer. A desktop computer, the attention that you pay to it is as luxurious. You can sit there, it's always in the same place. All your attention, it's fine. Compare that to driving in the car, getting an important message on your phone, and trying to answer it at the same time. The idea of driving is that you've got your primary focus here, you have your secondary focus in the rear view windows, you have tertiary focus on the pedal and on the steering wheel. And when you try to use your phone during that time, it dumps all of those temporary variables that you're paying attention to, speed and the proximity of things, and it focuses right on your phone. Trying to switch back out from primary focus to primary focus is why people get into accidents when they're using their phones. So why are we still building technologies that require the attention that we must give to a desktop application when obviously we aren't dealing with desktops as much anymore? One of my favorite quotes is that a good tool is invisible. By invisible, it doesn't mean that it doesn't exist. Right? There's a lot of people, invisible technology that you can never see, that's even worse. By invisible, we mean that the tool does not intrude on your consciousness. You focus on the task, not the tool. I mean, a really good interface is a book. A book is an incredibly great virtual reality simulator. When you read it, the interface, you dissolve into it if the writing is good enough. If the writing is bad, then that's the author's fault and not the technology's fault. And then you can hallucinate that, you know, a bunch of different characters that you might know better than your next door neighbor. Like, what a fantastic thing. It loads instantaneously. You don't have to update the software. You don't have to plug it in. You can spill coffee on it. It's still readable. You can put it into a stack of books for 200 years and it's still stable. Can you imagine doing that with some of the data sets that we have today? I mean, it just is mind-boggling. How are we going to archive any of this digital data? So let's talk about designing calm technology. So I went and looked through Mark Weiser and John C. Brown's work, and I tried to find some primordial principles. What could they say in the 80s and 90s that would inform the world that now exists in the kind of same state that they created in their own virtual reality simulation of what the world would be like in the future? So one is that technology shouldn't require all of our attention, just some of it and only when necessary. A lot of technology just kind of demands our attention randomly. Of course, you're probably familiar with the Skinnerian rat principle, where a rat is given random doses of food when it presses a lever, so it just presses the lever all day. I feel like that's how we deal with our technology. We're kind of clicking to find out whether the email is there. One way to do that is to put your phone in airplane mode, and when you want to check something, when it's time for you to do something, and uncheck it from airplane mode and actually do something about it. Instead of having something be compulsive and you're checking it constantly, you can kind of try and take control of that situation. Another one is to turn off most of the notifications on your phone, except for the most important ones. Or I have a system, it's kind of like a Morse code system. You can go into the iPhone and you can actually set up your own vibration. So I'll have like a dot dash style system. So a certain message from a certain person will be like one small buzz, like the tiniest. And then if it's really important, I'll have like 3 small buzzes. So that when I'm sitting there and I get a buzz in the pocket, I know what kind of alert it is. Is it important or not? Without having to look at it and use all my primary attention to see what it is. There's such a high resolution in our peripheral attention that we aren't making use of because we're so used to using all of our visual attention. We're missing all of these other senses. And so one example that the Mark Weiser had is the tea kettle. The tea kettle is really simple. The whistle is powered under its own system because you just turn it on and the heat makes the whistle happen. But you can set it, forget it, and it will call to you when it's done. It's really boring, it's really simple. These are things that we use every day. Speaking of things we use every day, why is our technology not like electricity? If your electricity goes out, it's a big deal. You call the electrical department and you say, my electricity is gone, this is a really big issue, electrical outages, right? This is something that we expect to work. We have electrical certifications so that somebody can come in and give us something that's stable within our own houses. The idea of electrification throughout places like the United States was a really big deal. We had large companies putting electrical grid in, and then we had tiny farms with small efforts to electrify themselves. This was a really big deal. And then all of the appliances were electricity. Now it's powered by electricity. I mean, this is basically what we're hearing now. It's Internet of Things, but this was electricity is powering your device. Now a new dishwasher. But the issue is that we can rely most of the time on that electricity. And yet we have these devices in our houses that we expect to work all the time, but not reliable. What happened to having something that was so connected and so reliable that we could use it just like electricity? Electricity is invisible. It's there when we need it and not when we don't. But connectivity is not, and that's a really big issue that will continue to happen in the future. As I said before, technology should empower your peripheral attention. This is the LumoBack. I'll just keep up that up there. There's this thing called the LumoBack Smart Posture Sensor. It's a pretty silly piece of technology because people tend to slouch all the time. So you wear this around your waist, and when you slouch, it will buzz you and remind you that you're slouching. So maybe it's called like a big mother, big daughter technology. It kind of tells, hey, sit up straight, but only when you're slouching. So after a while, you can sit up straight. But this is using haptics, just a sense of touch, and it's something personal, right? So I had an employee that was getting an insulin pump, and he was really excited. He's like, I'm going to be a cyborg. I'm getting an insulin pump. And I said, yeah, go you. Like, insulin pumps are awesome. And 2 weeks later, we were having a one-on-one meeting, and I heard a beep, and I said, did your insulin pump make noise? And he said, yeah. And I said, can you turn it off? And he said, no. This is the biggest issue. If we have technology that's closer and closer to us, we need to be able to change the notifications to meet our needs. Because this thing would beep during weddings and funerals, it would beep during films. And if he was in a nightclub and the music was really loud, it would beep and he wouldn't be able to hear it. So this is a personal notification, so it should be us so that he can feel it regardless of what's going on around him. And it's not broadcasting to other people that he has an insulin pump. It's for him and him alone. Now, I can see a situation in which you would want it to be in the case of like a nursing home where somebody's taking care of you. Then you want somebody else to be able to hear that beep and know when to help the person. But without being able to change these notifications, you have people that are stuck with something attached to them 24/7 that they can't change the notification. With that said, technology should inform and calm. It shouldn't be stressing people out around you, and it shouldn't be stressing you out. This is an example of a weather status lighting light. So this is a Hue light bulb by Philips connected to the internet with a real-time weather report, and it changes color based on the forecast of the weather. And there's a little iPad installed. This is my old kitchen. Little iPad installed into the wall, and the whole point is that I can walk into the kitchen, feel through the color temperature what the weather's going to be like for the day, and if I want additional information, I can look at the iPad. It's a pretty silly thing, but when you compare it to like the whole Microsoft ads that show up that are always about this person wakes up in their perfect condo with the perfect English accent, English American accent that the connected systems can understand the first time, which we hope doesn't work. And they get the weather report delivered to them by this disembodied human voice. It just doesn't make a lot of sense. Why would you want to wake up and have some computer talk to you in an intrusive way? We all know that we wake up, if we're not great at handling our technology, we just wake up and we are on the web for 30 minutes, reading all the latest news before we get out of bed. But we don't want it to be read to us. I mean, unless you're 7 and you really enjoy Alexa reading you the news at the deficit of your parents trying to like actually get something done. Technology should amplify the best of tech and the best of humanity. So if machines are trying to act like humans, it often puts humans on pause. So who's ever been into one of those parking garages that are automated and gotten stuck because the machine doesn't understand? And you have to call a human for help. I've been stuck between 2 countries before because I've been trying to go through some sort of passport control line and I have a QR code on my boarding pass and it got bent in my luggage and the scanner won't read it. And I've had to look around for a human because the whole system's been automated. So I'll like find the nearest security camera, jump up and down and wave at it until somebody, hopefully not on a bathroom break, finds out that somebody's jumping up and down and waving in the camera and they can actually like physically let me through. This is an issue where if we try to automate everything, the most important thing will become customer service. We're never going to be able to iron out those edge cases. But if we automate too many things in the wrong way, we turn the actions of people into acting like computers. And we turn all of the computers into trying to act like humans, which is very disembodied. Instead, if we focus on the best of each, you get something like Google. The whole point is that Google is indexing through all of these bots information that people have created. It's a people search engine. You're connecting with knowledge that other people have created. And you're not getting one result. That's why they took away the I'm feeling lucky button. You're getting many results, and you can curate. You as a human are not filtering through a million results. The machine is helping you 80% of the way there. And the last 20%, the context is what you're doing. If it was trying to make decisions for you all the time, it would be a horrible system. Nobody would use it. But because we have that choice, because it's helping us out with a little bit of that, it's amplifying the best of what technology does, which is sorting through lots and lots of information and presenting us with something that might match our needs, and the human aspect, which is the context. This is another silly example, but this is the sleep cycle alarm clock. So what you do is you plug this in, and it uses the accelerometer to find out how you're moving when you're sleeping, and it will wake you up in the proper sleep cycle before the time you want to get up. So if I set my alarm for 8:30 a.m., it will wake me up in the proper sleep cycle. So this is an example, 98% sleep score. I had a really good night of sleep. And you can actually see like the peaks and the valleys of when I was sleeping. And I got woken up at around 8:30, like right as I was getting into REM sleep instead of like deep stage 3 sleep. And so I might have had less sleep, but I woke up really happy because I woke up in the right way. So this is using the best of tech, kind of monitoring your sleep in the background, which you can't do because you're asleep, and then waking you up at the right time so that it like works with you as a human. I find this stuff really interesting. Technology can communicate, but it doesn't need to speak. We have all these disembodied voices trying to talk to us, and then you have to translate those into a bunch of different languages. When you can use something like a Roomba, that when it's done vacuuming, it goes da 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 da, or when it's stuck, it goes dum dum. And it doesn't try to vacuum entirely for you, it just kind of stops, and then you can pick it up and you can help it. Versus a bunch of robots that try to do everything for you. This is something that needs your help, and therefore it's adorable. It's like a Tamagotchi. These things are great. But it also has this backup light. It's green if it's okay, it's red if it needs cleaning, and you don't need to translate that into a bunch of different languages. Actually adding emotion through a sense of tones and lights to devices is a really good way to motivate behavior. There was a Swedish company that produced an art project that was called the emotive shoe rack. The whole point was to get you to put your shoes on the shoe rack, especially kids who, as you know, tend to leave shoes everywhere and you should open them at night. But what this shoe rack did is it just kind of like was happy when you put shoes on it, and it kind of like slouched down and was depressed if you didn't put your shoes on it. And so all of these kids were like, oh my gosh, we have to make this shoe rack happy. We have to put our shoes. We have to put our shoes on the shoe rack. And so it improved their behavior. Technology should consider social norms. The social norms change each generation of technology. These can change in a year, they can change in 2 years, they can change in 10 years. Let's look at normal technology. Right now, we all have phones with cameras in our pockets. That's normal, that's invisible, that's not a big deal. But 10 years ago, 15 years ago, well, 15 years ago now, it was, oh no, we all had feature phones, and now there's a camera on them, and oh no, privacy is dead, and we can't allow them in restrooms, and we can't allow them in stores, and everyone is going to take a picture of me walking down the street, and as we know, digital cameras are mostly used for taking pictures of food and putting them on social media. Below this norm line, which this is now the norm, 15 years ago it was just a norm to have phones, we have a kind of restorative line. Anything that restores you to the human norm, like glasses or a prosthetic leg, is restorative technology. It can look ugly, it can look weird, but it's restoring you to the human norm, so it's completely accepted. But then you have something that gives you something above the norm, which is considered enhancing technology, and this is what freaks people out. It's not equally distributed, it's mysterious, it gives you powers that are more intense than what the normal human has, like X-ray vision or the ability to record 24/7, which Google Glass can't, by the way. It has like a 20-minute battery life if you're trying to record persistently. But the issue is that they release so many features at the same time without understanding that there's a kind of metabolism rate for people accepting technology, which is like, or 2 years for each feature. That people just focused on the scary thing. So when the smartphone camera came out, people were used to these phones. And then this thing was the next step, having a camera in your phone. But it still took a couple years for people to accept that and to that to be embedded into the new social norms. With Google Glass, everything was released at the exact same time without understanding that this was a giant leap to have something on your face between your eye and somebody else's eye. And so it failed. And you could have predicted that had you understood all the social norms at that time. The right amount of tech is the minimum to solve the problem. I keep going into hospitals. My dad's in the hospital right now for a ridiculous illness, but so I got to spend all sorts of time in the hospitals and talking with all the nurses, and they have alert fatigue. It's alert, 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 and they forget the alerts, and they don't show up for the right alerts, and then big issues because of it, and they ignore patients because there's so many of the alerts. They're always the same alerts. Or they'll have like these smart boards that are in the hospital and then they have to do data entry through them. Why don't you just have a whiteboard? Like the number one thing a patient wants to know when they wake up is, where the hell am I? And what room am I in? And can I type that into a phone and have somebody come visit? There's plenty of other things, but why not allow somebody to just write it on the board? These are my favorite really boring pieces of technology. Streetlights are so obvious that they kind of go into the background secondary system of your brain, and they're kind of like punctuation for driving. Just, you know when to stop, you know when to go. These are ubiquitous, we understand it, it's really plain and boring. It's a series of lights. You can kind of see them out of the corner of your eye. And then the toilet occupied sign on the plane is just a pictogram that tells you whether it's occupied or not. Even if you're red-green colorblind, you can see what parts are lit. You can understand whether the bathroom is open or closed, even without glasses, if you're in the middle of a nap on a plane, and you don't need to translate it to a bunch of different languages. This thing exists for years and years and years. It's a stable piece of technology. And even though these things are boring and stable, that's the whole point. You don't need to take this part out of the plane and every 2 years upgrade it because somebody changed the USB port mechanism or something like that. Technology should make use of the near and the far. We have so many technologies that require an internet connection, but if you put your phone on airplane mode, how many apps can you actually use? You use like the notepad document and maybe the recorder and maybe a few of the other apps. There should be more things that work in offline mode. There should be more things that are downloaded to your local hard drive, and you should be able to at least do some of those functions without being connected. Because the issue is that we're going to have so many bandwidth constraints that these things should go to the web when you need them to go to the web, but not all of the time. Everything right now just kind of like goes to the web and sends so much data over that it's a complete waste of time. And I wish there were kind of restrictions on that, especially for websites. Like, you're now on a mobile phone, and it's kind of like 14K modem style to actually get into these websites, and you're expected to download 3 megabytes of JavaScript in the browser before you actually get to the content. I would like to see more 10K and 5K apart contests where you program the least amount of code to get something, which is why I really like early video game development. You've got like 24K of memory. You have to be really, really clever about how you program that. I would like to see that for the web and mobile so that we don't have these issues again. I kind of have this graph evolution of computers over time. We had mainframes that were far away from us, where like people like Bill Gates would wake up at 3 in the morning and sneak out to try and compute on them because they were so scarce. And then people had these personal computers with them, and so it was kind of a one-to-one relationship after a while, or a few people to one computer. And then what I call remote mainframes, it's not entirely correct, but in the cloud where we're just running on a bunch of mainframe servers again, remote from us. And now we kind of have mobile, but what I really want to see is this curve come down again, and we get into personal servers where our phones are just as powerful as an old server, so why not store some of the data and help serve that to other people? Companies like Netflix are already having issues with bandwidth constraints because people are all downloading Game of Thrones at the exact same time on a Friday night. But what needs to happen is we have more like BitTorrent distributed computing type models where you're just downloading a little bit from the computers around you and not as much from the main source. Because there's so much bandwidth waste and it's all duplicate data. So if you can process as much on the device itself, you end up saving a lot of time and misery for everybody, less buffering. So if good design allows people to accomplish their goals in the least amount of moves, then calm technology allows you to do the same thing, but with the least amount of mental cost. And as we all know, we want to automate things, but we don't want to automate hanging out with our kids. We don't want to automate a sunset, the appreciation of a sunset. We would never want to automate like enjoyable like life goal out of our lives. We want the computing to be in the background, and we want our primary tasks to be the clever things that humans can do, which are the insights around the data that we have, not being overwhelmed by it all. So the scarce resource is not going to be technology, as we've seen, but it's our own attention. And how we deal with that, how we build our systems, and how we restrict ourselves in terms of our data will make or break our ability to pay attention to things, our ability to be clever and curate, and our ability to build the next generation of tools should we so desire to do it the right way instead of distract everybody in our particular generation. There are 8 principles up at calmtech.com, and I wrote a book. It's available from Amazon and O'Reilly if you want to get it. I couldn't bring any of them, apologies, but you can ask me about it if you'd like. So thank you so much.
Oh, sorry. Anyway, so we have a few minutes for questions. So if anybody have any questions, please come up to the mic on the floor there for Amber.
Hi, Amber. Thanks very much for your talk. Could you talk a little bit about the effect of scale? Because a lot of the things that you described, 1 beep is fine, 50 beeps not so fine.
Yeah, this is a great question about scale. There's kind of, and there needs to be more research on this. But the idea is, if you get, however many alerts from a device or an application, there's a certain amount that you'll just get annoyed and uninstall the app entirely. So the question is, how many alerts can you get per day? And that's different for each application. right? So some people, if they're on their work email, they can get 350 alerts because all of them are important. They're trying to negotiate something. But if they get too many alerts for something that doesn't mean anything, then they don't. So I think, in a way, it's up to the individual about how many alerts they like, and it should be possible for them to change those alert styles, and how those alerts are delivered to them, so that they can make sense of their own reality. Because the minute we try to look at like a one-size-fits-all attention model for people, we end up getting into situations where some people will get annoyed because they don't get the right alert, and other people get annoyed because they get too many alerts. So I think one of the things is flexibility, like for instance, like a washer and dryer unit. Back when a lot of people lived in the suburbs in McMansions and lots of square foot, you would want to have something really loud in your basement telling you when these things were done. But now that a lot of people are moving into tiny condos, they want to be able to turn those notifications off. They're like the super loud buzz, so that they can run their washer and dryer at 3 in the morning and not bug the person next to them or get woken up during that time. And so in that case, it's, can you make something that works in both locations? Yes, if you change the alert style. Now people are buying things because of their quietness instead of their loudness, because of the smallness instead of the largest in size, because space and mental attention become more important. So I think it's just, if people learn more about like what bugs them or not, you kind of make a better way of alerting themselves and finding out what works for you. But if you're dealing with a world of these super annoying alerts that you can't change, then I would just try and turn your phone onto airplane mode or change your alerts so that they're off for most of these applications, which is tedious, but once you do it, then you are making an explicit decision every time you install an app about how it's going to bother you. So that was a really good question. Anybody else have a question?
Thanks very much. Is this on? We used to hear about information overload being a problem. Expansion of the web, is that enough? There used to be information overload was the big problem. And then, you know, the expansion of the web, is too much information, and it's how we're going to deal with that. Calming technologies could have been great, then big data's around. Rather than being information overload, it was give me more. And how do we break it down but still give me more and more? What role are calming technologies playing now that information overload is maybe not playing? It's just the fact that the buzz of the buzzword is away. Whereas the technologists have to talk about something new. and where is it that information calming technologies are still playing a role in the issue of information overload?
Sure, good question. Yeah, every few years there's a new word for information overload, and it's a great way to keep people talking about new trends in tech. I suppose that's a good point. Like right now, yes, we have information overload, and we have all this interrupted technology, and now we have a bunch of people that say, let's do Internet of Things, and let's do this thing, and let's give more information and more technology and more data. The reality is, we need people that are more wise than just informed, because the information can't do anything by itself. It's always a person that looks at that information and can come up with something clever because of it. And yes, the information is important, but if we just do it based on the information, you kind of seem like there's this post where there's this designer that left Google. They were very annoyed because they said, look, all I did during my design tenure at Google was test 54 shades of blue to see which one would keep people on the site more. And while that's fine, there's also the kind of human element. I've read stories of these like supermarkets where people are confused, like, well, all the data tells us that this type of product is not selling as well anymore. It's like, well, these dog treats aren't being sold as well. And until they had a physical person go into the store and watch the human behavior, not just from the data, they didn't understand that the dog treats weren't selling very well because they had them on the top shelf. And it was kids and grandparents who wanted to buy those dog treats because they wanted to hang out with these dogs, you know, and give them treats. And so you had to put them low enough that both the kids and the grandparents could get to them. And that's why their dog treats weren't selling very well. But if you look at the data alone, you'd stop selling the dog treats because you'd think, oh, well, they're just not doing very well. And so in a way, the information overload that you have all this data doesn't really mean anything after a while if you can't actually do anything useful for people with it, because you're just blind because you're just looking at the data. And so I'm always concerned when people are like, let's just do data science without looking at, like, where's the data coming from? Why is this happening? And actually watch somebody use something to figure out where it's coming from. Otherwise, we can make really bad decisions about things without knowing why. And then the data will tell us that we're doing the right thing, when in reality, we might not be doing the right thing. I don't know if that answered your question. What? Right. Yeah, the wrong data, yeah. So in that case, the data was wrong, they didn't understand why, but thankfully they had a person come in and check that wrong data. Sometimes people will not do that. They'll say, well, let's just trust the data. And who knows? I mean, it's always important to keep humans in the loop. We don't have any of those movies from the 80s, like War Games, as much anymore to give us reasons why we should continue to have humans involved in everything. But it's important because if we stop having that, then what do we have anymore? Like, our humanity helps us make better decisions. And I mean, unless you're like an evil human, and then we can talk about that, but I'm assuming that nobody in this room is. I mean, we're all here to do interesting things with information.
So I'm wondering, as all of these technologists keep making more apps, there's more data, people say, what can I do with it? There's just going to be tons and tons of things being developed. So I think it's helpful to speak to the developers and say, slow down, or speak to the world and say, smarten up, and just be selective in what technology you use.
Oh, can you introduce yourself?
Ethan McMahon from EPA.
Thanks. Yeah, I agree. Most of the times I speak at really large developer conferences, where I'm kind of telling this to like 2,000 or 3,000 developers at a time, being like, look, and this is why I moved to the East Coast too, because you get like a little bit more history in the things that you're creating, just because it's been around for a longer period of time. But on the West Coast, you kind of see, especially in the kind of bubble that we have right now, people just get funded for the same app over and over again. People aren't taking risks or doing weird things, which is why I'm not doing a startup right now, because the funding is available for doing a thing that looks really cool on paper, but won't exist in another 2 years. And I don't want to do something where I get 2 million users on a system and they become dependent on it, and then suddenly I say, oh, sorry, we're shutting down. Because that's, well, number one, it's rude, and number two, it doesn't make sense. Like, I would rather be a part of something that's been around for 40 or 50 years than something that's been around for 2 and is really exciting and really neat, but won't exist in a long period of time. There's a reason why I continue to use like X10 controllers in my house. If I want to do home automation, I use something that's been around for 20 years instead of buying something fancy new thing off the shelf. So yeah, so it's important to tell developers, like, you're never going to be able to tell developers to slow down, right? It's really cheap to make applications. But eventually consumers will understand that, like, hey, we can't use it. When they're hurt enough times, when there's enough Titanic scenarios where their pets die because of these systems going down or their webcams get hacked, hopefully people will say, I don't know about this new piece of technology. Can you prove that it's actually secure? Is there a backdoor? Is there, hopefully we'll get into a situation like that and people will kind of look through the marketing that says, this is an amazing new way to support your life. And they'll say, I'm so sick of all the technology I already have. Why do I need to? But we're not at that time period yet. And so we kind of just have to wait because, again, there's that metabolism rate that's, okay, I've been burned too many times by this thing. It's kind of like when people used to sell the like bridges. Remember, it's like, I'm going to sell you a bridge. People would come over to new countries and somebody would say, I'm going to sell you a bridge. Now you own the bridge. How many years did it take people to understand that you can't just buy a bridge from somebody off of the street and you have the rights to own the bridge? Like, that took a long time, right? So we're going through the same thing with our technology right now. It's like, yeah, this isn't a perfect thing, even though the packaging says it's perfect, and that you'll be able to have something that's amazing. And this is a big risk. I mean, I'm all for things like open source technologies, but when you have, or like new programming languages, but when you have a bunch of people who say, oh cool, like we're gonna all use CoffeeScript, and then in the next year they're like, well now we're gonna just use Go. And then you don't have any documentation, and you know, it's not that those languages are bad, but they're kind of like religions in some respect, where if you have a bunch of people that believe in them, it's fantastic, but once people stop believing in them and they migrate to a new language, what happens to all of the systems that are built in that language that don't have the documentation, that don't have the support, and then you try to hire somebody who knows some old, used to be exciting language, versus like having things written in a really boring language. Like, I'm a big fan of COBOL, like, you know, that's not necessarily like something people are fans of. But I would rather go for something that's stable than something that's very exciting, just because of that. It's those mundane things that are really interesting. I don't know if that's a popular opinion at all, but thanks for your question.
Thank you, Member Dennis. Give a round of applause. Lindsay is going to introduce her. So, hello, everybody. First, I did want to quickly mention that we do have a usability testing for NOAA One Stop outside, right at the table, which will be outside during all the breaks. So feel free to stop by for the NOAA One Stop usability testing. So my name is Lindsay Barberi. I'm a graduate student at the University of Vermont, and I've been a student fellow for ESIP for the past 2 years, and now I am a co-chair of the Earth Science Data Analytics Cluster and the Drone Cluster here at ESIP. And it's my great pleasure to introduce Christa Hasenkopf. And Christa Hasenkopf is an atmospheric scientist passionate about fighting air inequality across the world. She loves starting up environmental open data projects that give the public data, insights, and voices they previously did not have. Hasenkopf is a co-founder and CEO of OpenAQ, the world's first real-time open air quality data platform created by an open source community of scientists, software developers, journalists, and lovers of open data. She's also an Echoing Green Fellow and an adjunct professor at Johns Hopkins in the Advanced Academic Program. Previously, Hasenkopf was the Chief Air Pollution Advisor and Medical Director and a AAAS American Institute of Physics, Science, and Technology Fellow at the U.S. Department of State. Prior to this work, she was a fellow at the Global Development Lab at USAID. Before coming to DC, Hasenkopf conducted postdoctoral research on air pollution in Ulaanbaatar, Mongolia. With colleagues, she launched the first air quality instrument in Mongolia that shared data via social media. Hasenkopf received a PhD in atmospheric and ocean sciences from the University of Colorado, and it's with great pleasure that I ask Christa to come up.
Thank you. It's wonderful to be here, and thank you to ESIP for the invitation. I'm really excited to tell you about the OpenAQ story, and through that, hopefully, talk about how we've been working to incorporate, to really connect data with our community and users in general, and how it's really fundamental to our mission. And so the outline of my talks is pretty simple. We begin with air inequality And if you haven't heard of air inequality, it's because our small community sort of made up the term. But we'll talk about that and how it really motivated our platform. And then also talk a little bit about what the platform is and the community and what they're doing with the data that we're aggregating. And then 3 quick takeaways from what we've gathered from this project just over the last year and a half. And so air inequality is simply the unequal access to clean air to breathe across the world. You can see it a few different ways. You can see it if you look at the sort of global scale. It's actually the case that 1 out of every 8 deaths in the world is due to air pollution. That's indoor and outdoor air pollution combined. That's more than HIV, AIDS, and malaria combined. And this affects largely those living in developing countries, especially those in China and India. And so a different way, a more granular way to look at this is with this graph. So this shows on the y-axis air pollution, smoke and dust, annual concentrations, PM2.5 levels over the course of the year in these given countries. So this is each dot is a country. And then the x-axis is just GDP per capita. And you can see a pretty clear trend that as you go to lower GDP per capitas, you see higher values of PM2.5, or again, just pollution levels. If you bin these up by region, you see, probably not super surprisingly, a tendency for countries in Asia and Africa. If you're curious about those outliers, by the way, those orange outliers that are above that curve, those are Qatar, Bahrain, and UAE. Another way to look at this is through research that's been done in various countries and various cities relative to the pollution levels that they experience. So this graph shows on the x-axis the number of papers retrieved for various cities in a Web of Science search for that city's name and the term air pollution. So a not super exhaustive examination of how many studies have been published on air pollution for various cities, but it gives you a sense of how many. And not surprisingly, LA, London, Mexico City, Beijing, you get several hundred papers. And this is from the actual search. This is from 2011 data. And on the y-axis, you see PM10, or again, smoke and dust concentrations, the annual average value shown for each of those cities. And what's interesting is those red dot places. Those are from the 2011 WHO PM10 air quality database. The top 10 most PM10 polluted places at that time in their database. And if you sum up all of those red dot places, you get that dashed red line. So 41 papers have been published about those most polluted places. That's 5 times less than the number of papers published for Houston, Texas. And Houston, Texas has an order of magnitude of greater air quality. So it's stunning. And the thing about this is it's not just unfair or unequal. It actually truly affects our scientific ability to understand the relationship between human health and pollution. So before I show the next slide, I should reinforce I'm a physical scientist, I'm an atmospheric scientist. So when I look at health studies, I have to simplify it quite a bit. And so this is an adaptation from looking at the relationship, a simplistic adaptation of looking at the relationship between smoke and dust or ambient PM2.5 levels on the x-axis and the relative risk of mortality associated with that exposure to that air pollution. But very simple. So we know from studies, large cohort epidemiological studies in the US and the EU, a pretty clear relationship between pollution, PM2.5 levels, and relative risk of mortality. It's fairly linear. Now, if you go to higher levels that billions of people across the world are experiencing, you find that we don't quite understand that relationship as well. We have a sense through proxy studies and through the few studies that have been conducted, we do have a sense of that relationship that it probably levels out to some degree. But the exact way that it does is not entirely clear because of a lack of those studies. So in the most polluted places in the world where health is likely most affected, we don't have a clear understanding of that relationship. Yet what we do know is that in the US, and if we go back to this, in the US and EU, where we have that nice understanding of that relationship, but that's been garnered over many years through many different studies that rely on open data provided by governments. So as it turns out, if you look at the most cited large cohort epidemiological studies in the literature, 7 out of 10 of them relied on open data provided by a government source. And I should emphasize, they are the most cited, but they're more than that. It's not just research for research sake. These are studies that have had a huge impact on US, EU, and international standards and guidelines of how of air pollution policies around the world. So they're much more than just a given study. And open data provided by government monitoring really had a huge impact on that. And to give a more, I guess, personal connection to why I care about air inequality, as Lindsay mentioned, I spent a couple years living in Ulaanbaatar, Mongolia. Ulaanbaatar is actually, you might have seen it on that previous slide, it was way up there on PM10 or PM2.5 levels. It's a highly polluted place in the wintertime. This is a picture in the main square on a typical winter day, and that isn't fog, that is pollution. And it really gave a sense of working there. I was doing postdoc work on a rather detailed, specific aspect of pollution, but what I tended to think about most of the time was when I was walking from place to place is I can taste the air, yet I can't find an easy place to find air quality data that would inform me about what I should do with my day, or to anyone in the public in this one of the most polluted places in the world. And so at the same time, and actually just to give a sense actually of, this is current data that I just pulled off yesterday just to give a sense. So sort of the quantitative sense of that picture, this shows a time series of the past week in Ulaanbaatar on the X, the Y is just PM 2.5 levels. You can compare that with Beijing currently, and so you can see it's quite comparable and also currently higher. And if we look at DC right now, those are DC levels, the purple level on the bottom. So that gives some sense. It's above the WHO guidelines, or certainly the US EPA guidelines for PM 2.5. And actually, it turns out that these levels are comparable to what one would, they're approaching levels that one would experience fighting a wildfire, say in California. And so during this time while I was there, from 2011 to 2013, I had also, along with a lot of other people across the world, a monitor that was set up by the US Embassy in Beijing on their rooftop a few years before that. It started gaining attention though in 2011 during their apocalypse, where the US Embassy had put a PM 2.5 monitor. It was posting data onto Twitter, and it was amazing to me that it, among several other factors, but just this little bit of data, along with Chinese monitoring as well, it created a really large conversation that shifted the way that that air pollution is measured across Beijing and also China. It created a focus on a more health-relevant pollutant from PM10 to PM2.5. It expanded the monitoring that was done both in Beijing and across China, and there was greater transparency, a discussion around transparency. Why was Chinese data using a certain air quality index, and why did that vary from the US? This is a normal thing, but it kind of made it the community and the public talk about that. And so again, many other things put into this, but I was amazed that this one little monitor could have such an outsized impact on the community. And so, inspired by that, colleagues at the National University of Mongolia, myself and an American software developer, my husband, put up a monitor at the National University of Mongolia. And so we put our data out on both Facebook and Twitter, and also worked with some community groups to help get the word out about what that data meant, how to interpret it. And again, it really had and also the fact that it wasn't rocket science to set it up, it had an outsized impact on what it was. We received national and international media attention. The Mongolian parliament talked to my Mongolian colleague and called him in to ask questions and really elevated the role of data in science because of this one little monitor that we put out and shared this one little piece of data automatically. And so, inspired by that, and over the course of really a couple more years and various experiences that I've had, kind of put together this open data landscape that actually exists across the world when it comes to real-time government-level data. As it turns out, there's tons of it. So about 70 countries have ground monitoring done by the governments that share data in real time. We estimate there's 5 to 8 million data points per day that are produced across the world. And as you'll see, and as you can see here, they're all in disparate formats. They're on websites, formats, but typically the same pollutants are measured. That list there. And the other thing besides disparate formats is that they're also, some of them also temporarily exist. So they're not always there. Maybe it's on the website for 15 minutes on a table, that information gets updated, and then it's lost for easy access to the public. And so our premise seeing that was, well, geez, there's all this disparate data, and we know from both our personal experiences and seeing other experiences across the world that there's all these different sectors that can benefit by accessing that data. Whether it's the media and a data-driven article, public health policy, climate research, low-cost sensors and satellites for calibrations, certainly public engagement like apps and educational activities. You could really make a whole list of things. But the missing piece was that there wasn't really this transparent, universal data layer that connect all of these different sources of government monitoring data. And it was the case, though, and it still is the case. There's several different aggregators out there across the world. This is actually one of the best, aqicn.org, in terms of geographic scope. And so it also gives you a sense of where there's gaps, actually, too, in monitoring. But the issue is that all of these aggregators to date don't provide data in the way that we find most useful for connecting that data with all those different users, because they're typically they build upon that data in a particular way or particular avenue that sustains their company or their organization, which makes sense. But there wasn't something that provided real-time historical programmatic access openly for physical air quality data, not an air quality index. So that's when we came up with OpenAQ. And I should also mention, we did actually, before we started OpenAQ, approach various organizations to see if they were interested in doing this. We couldn't find that. For a long time, we did not want to build something that had already been built, just not quickly. But it didn't make sense for a lot of, for any of the organizations we talked to do it. So we finally decided we would build it ourselves, and we wanted OpenAQ. And we have 3 basic tenets for our mission. One is that we provide real-time historical data from government and also now research level sources openly and through an open API. And that the entire project is open source. That's so in 2 parts. One, we do want to just be transparent about how we're going about aggregating this data. The second is this started in our living room a few miles south of here with just 2 of us. We knew that's not nearly enough to really take this to where it needed to go. And so it was open source partly to get help, which we've gotten from various other people around the world who are doing their skills as well. And that this is community driven. I'll talk about it more later, but there's really no point in us aggregating this data and openly providing it if there isn't a community of users that are interested and invested in doing cool stuff and impactful work with that data. So this shows a sense of our coverage. This is from our website. There's a snapshot of our PM10 coverage. We have 7 different pollutants, but basically to date, we have data that we access from 43 countries. We had about 200,000 data points per day, currently about 35 million data points. and it's all open source. And so, are people actually using this data? The answer is yes. We have about 500,000 requests per month. This past month, we've seen research organizations, for about 700 or so research organizations have visited our platform to access data. And we also have a pretty active community on our Slack channel. Slack, if you're not familiar, is just our sort of virtual way of convening our community on a free chat service. So I'm going to get into a lot of the different uses that people across the world are doing stuff with their data. But first, I just wanted to give a couple fun examples of what things we've noticed lately. And so one cool observation we noticed lately is if we were curious at New Year's where we see air quality change when fireworks went off, and so we checked out a few places just for fun. Here's a few places. San Antonio apparently had really significant fireworks, so they had their monitor very close to the fireworks. This is PM 2.5 levels, by the way, and that peak is at midnight. And also in Chile and also in Norway. And we have a committee member who's actually going to be presenting some work where she makes a visualization of fireworks across different time zones and sees the clock at New Year's. That was a fun thing to notice. And another interesting one we saw recently was, you might recall back in November, the fires in Tennessee and I think Gatlinburg, and a community member actually noticed this, that they could see, this is PM 2.5 values over time again, they could see a bump 10 miles south at a station, an EPA station, due to that fire. And we thought this was pretty interesting to look at, but something else that was interesting was then comparing that data on our visualization in Delhi. And you see that bump turn fairly small, and you can see that air quality at the station in Delhi was lucky to get that low compared to that fire that was the station that was south of that fire. So what's our community doing? Several different things. So here's a few highlights from our research activities. So I mentioned we had a lot of different universities and research orgs accessing our system. We've also seen various organizations use our platform's input into their air quality forecasting models. And they've also tested their model output against data access from our system to see how well they're doing. We've also had, unconnected with us, but people have told us they've, in different organizations, have let us know after the fact that they've submitted proposals to NSF that have used our platform in some sense. And for policy applications, one interesting example we noticed, we don't have any, anything to point to at this sort of soon date to say this policy has changed or anything like that. But something we've noticed in our system is that when the even on policy, it's a short-term policy that was put in place in Delhi last, I believe, April, the second time it was implemented. Basically, it was you could drive your car if you had an even license plate at certain times, and you could drive your car if you had an odd license plate at other times. And so we had noticed that we saw a spike in requests for Indian data during this period that we have a guess was due to people trying to check out to see if there was any impact on that policy. And the other potential, use case we're already seeing for our data is people that weren't previously possible to do it as quickly. So the WHO publishes every couple of years an air quality database that shows PM 2.5 and PM 10 levels. It's used for a lot of policy purposes and policy analysis. One thing you'll notice this past years, and it's the most comprehensive ground monitoring database you'll find anywhere. But one thing you'll notice when you look at it, so that this past year there was 2,976 cities that were in this database, but most of that data, most of that annual average data that describes air pollution for that year, it actually comes from 2013 and 2014. The vast majority. Only 6 cities had data from 2015. So having data that's accessed from our system to give that annual average can be in the year that you're actually publishing or the previous year, be very powerful. And we also know of a group that submitted a proposal to UNICEF that uses our system so that they can build, and this is something we get a request for all the time from our community to build, is an open source alert system that pushes out air quality alerts via email or text, so that it's usable in any city and with locally specified air quality levels or standards and changeable by language. So in terms of media work that we've seen rise from this, few examples. So one is in Ulaanbaatar, a journalist published a couple articles, one of them comparing Ulaanbaatar air quality to Beijing, which is very common. Beijing gets a lot of media, international media attention, so people often wonder how their air quality compares to Beijing, and it can sort of jolt a given community to action. Similarly, in the Times of India, this journalist recently published a graph that compares air quality in Beijing and also Delhi, which is well appreciated in India that Delhi has higher pollution. But sometimes other cities besides Delhi go a little bit under the radar, even extremely large cities like Kolkata. So this journalist took data from our system and made a comparison between Delhi, Beijing, and Kolkata to draw attention to the fact that, hey, you should also be worried about air quality there as well. And then this is not a journalist, this is someone who is just in our community, but uses social media to make visualizations that often surprise me and a lot of other folks when she shares them, that accesses our data. And then this compares, for instance, this figure she's made, which you can't really see, but compares air quality in the water, how they include a place that's relatively well known amongst international air pollution circles, with a small town in Chile, and shows that, oh, actually it's quite comparable, the levels that you experience there versus in the water. And the interesting thing about this simple tweet is someone who lived in this small town saw it on Twitter, tweeted back and said, hey, I live there, let me tell you about it. And then she ended up interviewing the person and then published a little thing on our blog about this data, about the visualization, and about a conversation she had with someone who actually lived there. It was really interesting. So apps and chatbots, we've had a couple of different chatbots. One, the first one was from a software developer in Delhi, Aubrecht, who's made Facebook chatbot, and to be honest, I didn't even know what a chatbot was before he built it, but he basically made the system where you could say, I live in such and such city, anywhere around the world, and then it'll give you back air quality information. And then he also goes another step and then gives some guidance on what you can do in your community or where you could get various things to help mitigate that pollution. And then another group in India that we recently found out about that accesses our system is Hawabadlo. So they're an awareness campaign for air pollution, and they reach over 14 million people in India. So they've also built a chatbot within our system. And then probably most importantly, in terms of growing our community and getting more people access to build on top of the platform as well, is the open source work. So there's three different projects I wanted to highlight. One is a Python package written by a grad student in Boston. Another one by a statistician in Barcelona, Spain, in R. And then a data exploration tool that really inspired a lot of the work that we ended up doing on our platform from a software developer in Ulaanbaatar as well. And so I've given a couple examples of, quite a few examples of sort of what our community is doing around that data, but I also want to emphasize that we don't just make the data accessible and then stop. We also are a community that wants to make a statement on as large of a stage as we can about the importance of governments making their data truly open, and researchers as well. And so recently, last month, 12 of us from 10 countries, which are highlighted there in that picture, came together to write a commentary in Clean Air Journal. It's a South African, it's an open access South African journal. And as you saw in those previous maps, there's a huge data dearth in most of the continent of Africa. And so we came together and engaged, not just calling for more open data, but described what does it actually mean and what can we provide as a community to help make that happen. And so this also gets to the point of the statement, this commentary, those projects that have come out of it that people have built elsewhere will happen to some degree organically, but not to the level that we've seen. We feel pretty strongly that it takes an investment in a community, an actual act of aggregating interested people and giving them a forum to collect. And so we do that through a couple different means, one of which is through conversations, which we have on Slack, that Interface had mentioned earlier. We have a pretty active community, and that's where we have our most substantive conversations, I would say. And then also we're on Twitter, where people will tweet, in the Slack channel, they'll mention maybe something they created from our platform, but also anything in the open air quality space. There does seem to be a significant, there's a lack of a place to sort of congregate around air quality issues in various communities, and so we can act as a bit of a convener of those different groups. And then we're also on Medium and of course GitHub. And then the other way that we meet communities is in person as well. You really can't beat being in person somewhere. And so we do that through workshops. We've had one in Ulaanbaatar, Mongolia, since that's where sort of the seed of this idea began, and then also in Delhi, India this past November. And these workshops are not so much about us instructing or having great solutions to give anyone. It's really about convening different groups locally. And by different groups, I mean software developers, scientists, journalists, artists, people in policy, people who work at the air quality agencies actually running the equipment. And the goal of our workshops is one, seriously just to convene people and get them talking to each other about how they can be working with open data or each other to advance air and quality issues in their community. And it's also to see what people build and then take that back to our global communities. Because we saw people reinventing the wheel and not getting access to that wheel because of the disparate nature of these really valuable data sources. And so we don't want that to happen with what local communities are coming up with in terms of building out the platform or solutions that they're finding to work in their community. And so 3 quick takeaways of what we've learned so far in our brief time at doing this. One clear thing that I think probably everyone in this room agrees with by the nature of what we do is that data means nothing, and they have no impact without a data ecosystem or really a community built around them. I think for us, it motivates entirely what we do, and for all of us. If you don't have a community of people using your data, who really cares about that data in the first place? And the second thing is that it's essential to connect across community silos for making progress. We've seen this, one quick example that we've seen our community say just this week is a small example is a journalist in Asia really wanted to make a data-driven graphic article featuring annual average or I think weekly and monthly averages of pollution in her location and wanted to do analysis in comparison with another place. And she didn't have the skill set to do that. So she went on to her Slack channel and said, hey, can anybody help me with this? Someone in Europe said, yeah, I can help you with that. It expanded the fact that she felt comfortable posting that question and then that someone answered was really powerful and makes her product better, and it also makes that scientist who helps out maybe use their skill set in a way that they might not have initially envisioned. So it seemed really powerful. And I would also say for us as an entity, we only exist because of connecting across silos. I myself could not build this platform. I'm not a software developer. I can do very, very little of the infrastructure behind what we do. That said, my co-founder, who is a software developer, wouldn't necessarily have had the vision or implemented the same same way he doesn't have an atmospheric scientist board either. And so I also think this is going to be an issue that's especially important as we're going forward, because I think a lot of the different silos boundaries are shifting. So we think of the data ecosystem community in this very broad way of bidding up different groups with data producers, technical users, and general users. We see some overlap, but I think the air pollution community, but also many other communities, anything involving with personal sensing is going to see that data producer community expand into general users. We're already seeing that. And I think it's going to be especially important for us to make sure that the general users who are producing data are connected well with technical users and the more traditional data producers to be able to interpret the data that they have. And the third takeaway is that strong communities don't build themselves. I saw this is an article that came out in Nature, I think it was a commentary last week or this week, and it's summed up by this caption. It said, researchers must venture beyond their comfort zones to engage with citizens, and they should receive credit for doing so. I totally agree with that, but I would also say it's not nearly enough. It's really, really valuable to have conveners and connectors in order for a data ecosystem to exist. I think if you really want to grow a diverse community, a strong and sustainable community, you need organizations and people dedicated full time, and to see the value of dedicating them full time to convene and connect, and to really be the glue of a data ecosystem. I don't think there's any shortcuts to doing that. So those are our three takeaways in the year and a half that we've existed so far. So that's all I have. I can definitely share. We didn't really get into the technical architecture of our platform, but I'm happy to answer questions around that or anything else. I do want to thank ESIP for the invitation again, you for your attention, all of our organizational partners and sponsors, and I always have to thank the entire OpenAQ for doing what we do.
There is a more interesting presentation talk. It really resonated with me the takeaways, ESIP spirit about the community at first. We have a few minutes for questions. So, any questions from the audience? Please go up to the mic. Hello, yes, thank you for your talk. So I'm Lindsay Barberi again. Hello. With the University of Vermont, and my question is, did you have any other open data communities that you looked to, or other organizations that were doing sort of similar things that you modeled off of, and what communities were those? Is the first question. And then follow up, do you have any thoughts about other sort of sectors or other problems that might be able to, that you could see this as being a really good platform or way forward for some of the other science communities to think about?
And the truth is, when we first started off, it seemed very clear that this, to us at any rate, that this platform would be very valuable to have in edge cases. I didn't know anything, honestly, about open science, open data when we started off. So it's been a definite learning curve. But what's been great is we've attracted, and this is, I think, natural, the first people who are attracted to our platform are other open science, open data, open source communities, and they've been teaching me. So we look to our open side, for instance, a few other groups, primarily our open side for their model and how they've done things, public labs, and that's all been through other community members saying, hey, I see you're trying to figure out this thing. This has already been figured out over by this other group, you should really talk to them, which has been good. And then in terms of other ways that this can be used, I mean, all of this system really does is fetch data, store it, and then serve it out quickly. So it can be used for a lot of different things. What we get the most requests for and interest in is somehow to apply to water quality. We, for instance, wouldn't ourselves build a water quality database for participants. I don't know if we're qualified to do it, but I think our system's entirely open. We talked with a couple primarily individuals who are interested in building something like that. I think there's a big need in the water quality community for a similar effort.
Hi, thanks for a great talk. So I'm associated with the Harvard Center for Geographic Analysis, and Lex Berman there has been working at searching for and finding not only government but private sources of weather and air quality data there. I wonder if you could talk a little bit about the sort of crowdsourcing issues of, you know, people providing data that maybe is not provided very accurately by the government, but has the crowdsourcing issues of quality and anonymity as well.
Yeah, that's a wonderful question. And you know, to start off with the fact that even across the government sources around the world, there's not an assurance of data quality. You know, our system, we actually don't ensure any data quality because we're simply accessing it from government systems that have varying degrees of how they measure their data or varying degrees that we can even know necessarily. So that's an issue right there. I think, so for us, and I didn't really talk about sort of the future of our platform, we have a layer that's for research grade level data. We have a placeholder for what we're calling right now other data, which is essentially low-class sensor citizen data, but we're going really slowly around that because of the issues you mentioned. First of all, there's not standards, but there's also a lot of open questions. How you display that responsibly? If you have this data that is coming from these different sources, how do you convey, with real questions about low-class sensor accuracy, how do you convey that information on a map that doesn't make it look the same as a government level source and is taken with the same sort of weight? So we're very interested in doing that, so we're proceeding extremely carefully and talking with a lot of different groups on both the crowdsourcing side of data measuring of low-class sensors, and also on more traditional sides, because I think it's going to take talking with folks to figure out how to manage that appropriately, responsibly.
Hi, this is Ethan McMahon from EPA. I think this is great stuff, and I think you're really onto something here, opening kind of a public resource. Since you have a lot of government folks in the room here, what do you want to tell us to do that will complement all of this energy that's happening outside of government?
So for the U.S. data, so speaking from the U.S. data perspective, so there's two perspectives really. The U.S. data has been, I mean, I'm not saying it's the Plenary, it's been one of the easiest things for us, countries for us to add the data, because open is not just data on a website, on a graph somewhere that has to be scraped, it's truly accessible. So that's been huge for us. What we are trying to communicate with other groups that we talk to, other agencies that we talk to across the world, in recognition that often bandwidth in terms of time and human capacity and skill sets and funding, primarily, to be honest, are not always there. What exactly, why it's not enough to put data stuff on a graph elsewise. So I guess that's been our big message to various groups. And we actually point to the U.S. source of how we get data as one of the more robust ways that we have to do that. Now, the second part of that is I don't know what leverage or what avenues would make sense for U.S. government folks, but to take those tools, which I already know they do, having been at the State Department working with EPA, but take those tools and help various other places figure out how you guys are going about the way you're doing. Yeah, that's
Questions from Christa? If not, let's thank her again. This is what I'm going to introduce our next friend.
Hello, I'm Johanna Boza. I'm a second-year fellow with ESIP, mostly working in education. And I'm pleased to introduce Frank Niepold, who is the Climate Education Coordinator at NOAA's Climate Program Office in Silver Spring. Also, the Climate.gov Education Section Lead, co-chair of the U.S. Global Change Research Program's Education Interagency Working Group, the Climate Action Report Education Training Outreach and Outreach Chapter Lead, and that's just to name a few of Frank's many hats. He's a true collaborator, and I know him to be integral to and binding member of the climate literacy community. I've had the privilege of working with Frank through my ESIP fellowship experience with the Climate Literacy and Energy Awareness Network, CLEAN, which is a group that facilitates dialogue and collaboration between members of the climate education community, as well as provide curated education materials. Frank has really been a key member in bringing the CLEAN network to the next level, and also thinking big, mostly exemplified in our recent new status as a cluster at ESIP. Without further ado, Frank Niepold.
Get this just right. Sorry, I'm height challenged. So it's a great honor to be with you. I'm going to go slow today. I usually go fast, so I'm going to go slow because this is really, really important what we're doing here at ESIP. The climate literacy push in the United States started in September of 2005. And I was given a mantle, a mission by NOAA, by U.S. Global Change Research Program to make the nation climate literate. We had no idea what that meant. So the first thing we had to do to define it, and we had no resources, we had no budget, we had no programs, we had no community, we had no networks. And we didn't have much of an understanding of our history. It turns out there's a lot more history there than we thought. But one of the things I'm thinking about you guys and where you are and why the ESIP community is such an important piece. And I started, joining this community back when I was with NASA under the Landsat mission. But the idea of education, I mean, the previous talks, the connection between data, societal applications of information that we use, and education was made. But I'm going to try and unpack that a little bit more. And one of the things we've been doing as a community that has grown up around this is really strengthening the critical aspect of education. Because a lot of times it's an afterthought. It's we're doing this thing and then there's education over there. And it's like, it's just over there. But I think what we are coming to realize is that it is a critical piece. Especially the topics we're talking about, the issues that we face and the move on those issues across the world, these are multi-decadal issues. And if you don't think about education as a critical piece of multi-decadal issues, you're going to continue to run into the same wall over and over again. We know what that means. It's kind of insanity, right? So maybe it's time to stop thinking about it that way and really take a serious look. And I think ESIP's leadership is helping us do this, at how do we build the capacity to understand, utilize, and move forward on this data. So this idea in your strategic plan about connecting communities to observations is a really critical and important piece of it. And I appreciate that the community has made that commitment. And so we're going to look at that and how do we really move forward on that commitment in a serious way. Johanna, who introduced me, and I'm very pleased to have her as a partner in our community, and I were part of the COP21 Paris Agreement. I was representing the U.S. government on youth engagement and education. It's part of my many hats that I wear. And, we also had the honor to be part of the President's Climate Action Plan that was highlighted in Paris through education and literacy which we just are closing out in 10 days under this administration. It's a great honor to be part of that. But the thing that came through in the Paris Agreement was the world pivoted. The world said, we now fully accept the science that our community and beyond has been working so hard for so long to make the case that this is a critically important issue, an issue among all issues. In fact, some people make the case that it's the super issue, the issue above all issues, because of its impact across the centuries, and across the decades, and across the generations. So, but if we're going to do that, and just to give you a little clue as to how I use colors, anytime I'm talking about green, in this the image, I'm thinking about something where your community really needs to help us. So I'm just trying to signal to you, when I use green, some of the text and the language we've been building across the years is now pivoting to skills. Because if you have access to information, and you don't have the skills to use it effectively toward your outcome, I think it's another aspect of just having access to it, which we've seen in the previous talks, is tremendously important. But if you don't have skillful use in using that information toward your outcome, I think that we haven't gone far enough. And so we've moved from knowledge and awareness into skill development toward making better decisions. So, that's part of what we were doing there. But in order to build those skills, both within the United States and beyond the United States, is a very substantial amount of work. It's going to take a long time, and it's going to be slow and thoughtful work. So, let's hopefully we can do it together. So if you look at the actual agreement, and then the fact that this actually happened, 21 years we've been struggling to get this agreement. And we completely restructured the way we get that agreement, individualized, commitments, not as top-down, legally mandated commitments, and that opened up the space. But inside of that, Article 12, which says that education and training and capacity building are key to the success of the agreement. Now, most of the focus was on other parts of the agreement, as usual. Because again, we always focus on the non-education stuff. The education is taking care of itself. I think we can say that's not sufficient. The education piece is not taking care of itself. Because the students that are in school and the citizens who are out of school are non-skillful in using our information to make societal decisions, personally or in a community context. Does anybody refute that statement? I'm going to take a little while here. Does anybody refute that statement? Because if you don't refute it, I think it puts us in a position to be capable in solution for it, right? We have to be part of that solution. If you're a community that cares deeply about data, skillfully building and using data, you have to be part of the process that actually builds the societal skill to using that data for societal outcome, right? So, we're giving you platform through our new cluster to join us in that enterprise. Now, we've talked about this for a really long time. Back in 2010, 2009, Congress chartered NOAA to fund the national academies to come up with something kind of unique. How many of you remember the American Fund choices? Wow. The NRC has got to do a better job because this was really important work. Because what the Congress said was, tell us what we should do about climate change. Usually they don't do that. They just say, give us a sense of the understanding of the community, but don't make recommendations. They actually told the NRC to convene panels to tell them what to do about climate change. Now, in 2010, one of them, they called out education and communications as critical pieces of, this. I've always liked this idea of bringing the hidden hazards to the public attention. Now, I don't think, attention, understanding, and action. Embedded in that is actually that they are skillfully understanding how to use our information in order based on that hidden hazard. But it's in there. But again, that you testified that it's the case. Yesterday, the U.S. Global Change Research Program, which I'm honored to be a part of, released its triennial update for the strategic plan. That's a new word. I've never heard of triennial update, but there it is, every 3 years. And in there, it continues to affirm that we have a goal to communicate and educate, to advance communications in education, to broaden public understanding of global change, and develop scientific workforce for the future. So, but in order for us to actually do that, we need a much bigger engine than what we can do through just the federal agencies. So that's part of why ESIP is such a critical piece of this. I appreciate that something that my office is part of, and members of this community are deeply involved in the Climate Explorer, and as part of the President Obama's launched toolkit, the Climate Resilience Toolkit. But I venture to say that this work, as critical as it is, if we don't build the skills within communities and decision makers to use this information and the implications of it, and this is model output, not just the observed data, but if we don't build that in communities, their ability to use the tool is, we don't give people advanced tools without training. And that training is also important in society for education. Remember, 1 in 4 people in the nation is a student. That's a little different. It's between 1 in 4 and 1 in 5. 1 in 4, 1 in 5. That's a really large segment of society, and you tend to spend something like 20 years going through formalized training. However, so this is a picture I found of a school in Philadelphia. I was, in 1971, I was in 72. I was starting school in Philadelphia. It's 1972. I'm now 51. What I learned in my classrooms between then, in the public schools in Philadelphia, I went to England for a little while, I went to college in Temple University, and went to college for 12 years. It wasn't until I went to Johns Hopkins that I really started seriously in my advanced degrees, getting into the stuff that we talk about in this community. I had almost no preparation in those sciences at all. I had to reteach myself our sciences because I was asked to teach it. So we have to appreciate that the other people in this image, who are my peers and our peers, really, in this country, uniquely in the world, care to use our information. They don't understand it. They have really core misconceptions. They really don't have the skill in order to use our information. I'm trying to emphasize, and maybe I hit that nail so hard the nail's a little piece of wood. That's okay. It's worth it. The work that we do as a community is dealing with an adult population that really is not skilled. Solving that requires a unique set of strategies, but let's not only focus on that community while we have an opportunity to work through the education systems, formal, informal, place-based, and really build up their skill with the stuff that is so important now. If we don't do it then and keep on focusing on the reactionary approaches to adult education, which is really, really, really hard. It's much easier, it turns out, to work with kids when they're in a formative stage and they actually have to do it. And the teachers are both focused on these issues. So let's look at that as well. So in order for us to put some guide rails on how to focus on this, back in 2009, we set up a framework, climate literacy framework. It turns out just writing a document turned out to be a pretty powerful thing to do. It's guided a lot of the standards that are being used across the nation right now. It's guided programs that were federally funded from 2008 to 2020. Now the funding curve obviously has gone down. It'll come back. But this turned out to be an incredibly important framework for how to move forward on this issue. However, actually, I'm going to go back a step. However, in 2009, we didn't appreciate the reality of how important the skill development was and how the interplay between data, decision-making, and model outputs to decision-making was as we do now. We called out certain things, but we really didn't get into the core elements of what your community focus on here. So we have to augment that approach. And it's been an evolving organic approach. But I think that the data science and the media literacy related to data science has shown up as more and more important over the years. So I'm going to focus on that a little bit, just so you can see that. But there's another aspect that I'm going to reinforce this point. Triangle is the U.S. Global Change Research Program's approach to how they do their work. You advance the science, you prepare the nation for change, you assess the climate science. I'm on the steering committee of the National Climate Assessment. It's a critical piece of what we do in this room here as well, pieces of it. We provide the tools to make science accessible, all toward the decision. Sometimes the decision maker is the mayor, sometimes it's the governor, sometimes it's the officials, sometimes it's a citizen. But all of the blue circles is what I've been focusing on, which is if you focus only at the decision maker at the time they make the decision, you've forgotten about all that work that we're building, the skill and knowledge and approach, how the decision maker makes the decision, which is for decades before that decision point. If you only focus on the decision point and the social context of that decision, it's going to make it really hard. We're in a democracy. We don't make decisions by ourselves. We have to work within the context of constituencies. So if we are trying to focus on that, but realize that that means we should have been doing the work that we're talking about 3 decades ago, 4 decades ago, in order to have the citizenry and the decision makers ready to use our science now. So that you could say that that's a failing. It's a challenge. But if we don't focus on the decision makers and the social context now in the youth that we have, in 4 decades, 3 decades, we're really going to have a hard time using our information effectively, while also dealing with the adult population that is currently making those decisions and supporting those decisions in a variety of different ways. So it's an interesting, vexing problem. But good news is, partly what we did through the White House when we launched, expanded the President's Climate Action Plan for education and literacy, was to convene meetings at the White House. Turns out when you have an invitation from the White House, people just show up. They don't ask for travel support, they just show up. It's an amazing thing. It worked. We thought it might, and it did. And a lot of youth came in due to the leadership of some of my colleagues at the White House. And what they did was they actually convened meetings with young people who have already demonstrated an interest in these topics. Ask them, why is this important to you? What do you want to do? How are you feeling supported? And they had a lot to say. And so that's Gene McCarthy, a key person in the Climate Action Plan, listening. John Holdren was in those rooms. A lot of key influential people in this administration who have a lot of really important movement on that decision space. And they have some interesting things to say that I think are germane to this conversation. Ooh, that's not going to work. Sorry, guys, I didn't realize there's room dynamics. But I'll give you a couple of key pieces, right? They want an opportunity to lead. We learned this in Paris extensively. Young people who are in the 10 to 25 range absolutely have a voice on this issue, on global change. They want to be heard. They don't want to be the decision maker in the future. They want the decision makers to hear from now, because they think that the issues that are being decided on now are actually critical to their future. And they don't want to wait to be the decision maker. They want the decision makers today to hear them. So, really important piece. They're not shy. They are really bold and powerful. And I mean, it's an amazing thing to watch as an educator. They want cultural differences to be appreciated and respected. They want to be connected to this issue. They don't feel the time on this issue in what they focus on in school and educational programming is anywhere near sufficient to what they feel is important. They feel like they're getting focused on all these unimportant, less relevant things, when this really big thing and the educators are avoiding. Stop that. They want another really important thing is they want this integrated across the curriculum. They don't want to just focus on this in the science classroom or even in earth science classroom. They see this as all over the curriculum, and we should be acting as such. Clearly, the issues we talked about here show up in a lot of different parts of the curriculum. Challenges us very hard, but that's okay. It's our problem, we should fix it. They definitely want it to be focused on the interdisciplinary, as I said, but they want opportunities. They want to step up, and so I think one thing I think I'm looking in the room, if you have young people who are in, say, middle school or high school, they're willing to work really hard for you free. Any day of the week, connect. They want those opportunities. They're brilliant young people that I think that if you give them the opportunities, they'll run hard. Not all of them, trust me, I know. But some of them. But they want to jump in there, and I think if, as I gain, understanding across the years as a teacher, there's a lot of more you can do beyond the classroom that opens up space. And Amber, I think you mentioned Bill Gates used to jump on a mainframe at 3 in the morning just to get access. That's one of the reasons why that 10,000 hour rule. Well, they are ready to jump in, and so I'll give them the opportunity because they're going to do brilliant things if you give them the access. So just another thing to say. This is just another way of looking at it. I just grabbed a one high school in one city and looked at their science curriculum, and you think about the conversation we were having, and you think about that, it shows up in a lot of parts of the curriculum, because we have a really structured, I'm going to get on the soapbox for a second. I haven't already been on. We do a great disservice to our science innovation. When it comes to high school, we do not take earth science or system science anywhere near seriously. It's one of the hardest, the most rigorous, and challenging sciences I've had in the 2 decades between NOAA and NASA to work with you guys. I get it, but I mean, physics, chemistry, biology in high school, and then AP physics, AP bio, AP chem, and anatomy and physiology. Where's earth systems? Where are they? I have to edit myself sometimes. It really bothers me a great deal that we take this science that we've been doing for centuries, decades, and take it to such an important level, and yet we do such disrespect in our schools by not approaching it seriously. The kids want it deeply. Not all of them, they'll get there. They love it when they do. But if you look at this, there is no earth system science. There's no AP earth system science. It's not there. So there's some really structural challenges before us. But another opportunity for us is these new standards, the next generation science standards, the NRC framework for science education. They've been adapted and changed a little bit by some states. It's the most dominant science education form that's going on right now. And key to this are these science and engineering practices, which is embedded in the content, not like you learn the practice and then the rest of the year you just remember information. Look at those circles, and the reason why all those lines are connecting all across is because you don't learn one and then the next and the next. They're all interchangeable and interwoven as we do the scientific process. But some of these are skills that are such critical pieces to what we're doing in this community. If we have the ability for the next couple of decades to really build up in our students these skills, it'll be an investment in the future that will yield when we are struggling with the next phase of the science that we do with data access and using that to make informed decisions domestically and beyond. This is going to pay a huge dividend if they do it well. You guys live and breathe this. A lot of these pieces, your expertise inside the educational system, teachers do not know how to do this stuff. This is freaking them out. And there's no support for them. They've been told to do it, and now they don't know how to do it. The more you can do to show them how do you obtain, evaluate, and communicate information, I think you guys have something to do about that. If, asking and answering questions based on data, really important piece. Engaging in argument from evidence. I think you've got something to say about that. That skill that you've built up is worth making the investment backward to make sure that the next group doesn't have to work as hard to get as advanced as you are. So another piece that I'm the parent of climate literacy for the U.S. And we didn't really get the data literacy part right. And there's different people who talk about this and think about this. I don't know if our communities really sat down and thought about what does data literacy mean, but it's really about critical I think that those previous standards are embedded in this, but information literacy, I think we already talked about this in previous conversations about how to access. That whole point about citizen measurements of air quality and whether it's skill and quality information and being able to derive, that's not a really good measurement because it came from this source and it hasn't been reviewed. But don't make a decision based on that, but look at this other data. That's a sophisticated analysis that, but there's a lot of spurious information out there, especially about climate and global change. Sorting through it all, really piece. Statistical information, I've come to appreciate AC statistics and probability so much more than I did historically. So, and then just general data literacy. I think we as a community might be positioned to have something to say about this. Oh, that didn't come out right. So there's some, I don't share the slides. If you guys want these, if you want, just let me know. Because there's some nuggets I've been looking at, and this is from librarian science. Really fun. I find librarian science to be incredibly important. I've always loved librarians in schools. I didn't appreciate how important they were until after I left the schools. I'm not going to get into too much detail, but there's a lot of rich thinking that I think is important for our community to consider. But I don't think it's far enough because Matt Nisbeth, part of our previous work, called out that it's not just that, it's also in civic skills and media literacy. So it's just the data literacy, but then the application of access to data through media is another piece of that. And I think that Matt did some really fine work in calling this out for us. If we haven't realized that citizens have a hard time sorting through credible post-fact information, we got to help them. And we do credible work and we do it carefully, but if they see one data plot versus another data plot and they don't have the ability to discern which is credible, which is not yet, we have to do a better job of that. But I love this photograph. The reason I love this photograph is because it's not just about all of what we've been talking about. It's also about jobs. We realize that our economy is not working for a lot of people. Education is critical to jobs as well. We build the future workforce. This job right here is the fastest growing job in the nation. Bet you didn't know that. What this job is a person goes up on a wind turbine, they love ropes, climbers, you know anybody? They got a great opportunity. Because this person slides down the front edge, the leading edge of the wind turbine and looks at cracks and deformations and erosion on that to make sure that the blade doesn't fail. If it fails, the whole thing blows up. And usually there's a second person on the backside, they do it in pair. This is the fastest growing job in the nation right now. Faster than anything else. Solar installers is right up there. Coal miners, not so much. I'm not making a political statement, I'm just looking at the jobs. But these people are early entry jobs, the people that are really having a hard time making it. This move that came out of Paris is going to push us to go into very rapid energy transformation. And it's going to change the job. But this person, I remember when I was talking to climate change with a 7th grader one time, and he said, yeah, I think I get your point. But he asked me the best question I've ever been asked. And I'm going to open up the questions in a second, so I don't mean that's a setup. But, he said, I get this, but are all the jobs going to change? Because what I want to know is, I'm 7th grade, what am I going to take in 8th grade, and 9th grade, and 10th grade, and 11th grade to prepare me for a job? Which job should I prepare for? This is a job. This is a real job that you don't even have to have a college degree. I've backed off on the importance of college degrees. It's a really hard thing for a teacher to say. But it turns out there are a lot of people that aren't going to go into college. They're just going to go directly into a trade or a workforce right after high school. This job you can do a good salary, stable. This is going to be around for a really long time. So I think that there's an emerging priority here, but I see that because the climate change is bringing economic challenges, but it's also bringing huge economic opportunities. We need to highlight where the opportunities are, because the motivation for a kid to really focus on the stuff we're doing also relates to jobs. And this is just one job. There's a lot of other jobs out there in this emerging sector. But I want to just close out my remarks with thanking the ESIP community, because you guys have accepted us as a customer. as the clean network. What the clean network is we knew back in 2008 when we started this that we needed a community. We didn't have it. We've grown a community outside of ESIP. And now ESIP is giving us an opportunity to add some more structure, more support to really doing the hard work of building network and building community response, building a collective impact. And we wouldn't be able to make the pivots we're making right now. Clearly, the federal investments in the work that we're doing are going down. We're the first to think of this. Data, you guys are going to probably have servers and observation networks for, without any challenge. Education, we're already zeroed out. So we're going to have to transition all of our work into the community. Community partners are going to play a critical role. They're already showing up in droves. We need better network structure in order to work through external channels as opposed to internal channels. This is something that you guys, whether you knew this or not, ESIP has done this for us. And we have a great deal and support, and we would love to have you work with us to move that forward. This is one of my favorite photographs. The reason why it is, for the longest time, for a decade, I've been teaching about climate change, and I could feel the seats in the room get deeper and heavier from the weight of people sitting there. All I was doing was talking and showing images. This is actually the winners of the solar decathlon a few years ago, and these guys are not feeling the weight of the world on them. They're figuring out how to redesign their houses to work at zero carbon, zero energy capacity, and actually be houses somebody would want to live in. And they're stoked. They're excited. They see this opportunity and they are running full steam at it, as opposed to feeling demoralized and taken down and depressed. Stick their head in the sand as a result. I need more of this. We need more of this, because that passion and that power and that enterprise that they have is an immense engine for us. Remember, 1 in 4.5 people is a student. These are students too. I can't remember which university they're in, but this is amazing work. And the more we can move this forward, the more we can transition to this new economy that's happening worldwide. We didn't even talk about resilience. That's a whole other issue. That's important too. Anyway, I should probably stop there. If you have questions, I'll be more than happy to take.
Indeed, this is amazing work. Thank you so much, Frank. I feel your passion about your work, and I really appreciate how you have contributed to this cluster. So it's so inspirational that now I want to jump right into that cluster. Anyway, so we have questions there, Frank?
Howdy, Frank. Brian, we from Neptune & Company, environmental risk management firm. So, Frank, question goes to you about 21st century skills for the emerging workforce and how that may be to not quite offload climate literacy, but use and leverage issues about climate literacy. I mean, so what inspired me to think about this question were your slides. You had a slide there about science and engineering practice, and you had a slide there about critical thinking, which reflected a lot of the work behind reports by the National Education Association and also industry groups, very critical industry groups like DuPont and I think 3M and those other guys who said, look, there's a series of critical thinking skills for the emerging workforce for the 21st century, and amongst them are critical thinking, communication, which is something Christa pointed out in her talk. And I can't remember what are the other ones, but collaboration, critical thinking, blah, blah, blah. So the question goes back to you, since you expressed concern about future funding for explicit climate work, and the fact that these 21st century skills have been also called out by industry. How do you see yourself, your community? Not again, I hate to use the word offload, but how do you see that critical thinking skill work that you'll be able to leverage that to your advantage?
So there's an interesting body of work on skills Developing skills is one thing. One of the things that's really important in skill development is this idea of transferable skill. Sometimes what happens, there's educational research to support this. So, what happens is, if you build a skill related to an issue, sometimes you put it in a silo and you only use that skill in the context of that situation. You don't use it as a universal skill or a transferable skill. Use it only in this instance, and then when you come up with another time, you should be using that skill. You don't because you think it's only applicable over here. So that's one piece of it. The second piece of it is relevance in learning. It's a really, really important piece. Turns out, remember this photograph of the students at the White House with Gene McCarthy? They are highly motivated to learn because they see climate and dealing with climate change as something that is utterly important to them personally. They are motivated learners. I got kids, my kids, I'm a proud father, but sometimes they drive me crazy because they aren't motivated to learn. Until they get motivated, the engine to do the work of 21st century skill development personally, as inside the student, is really challenging. Turns out these issues that we deal with are incredibly relevant to what they want to learn about. So if you couple relevance and 21st century skill and transferable skill, you get a really nice nexus. The stuff we care about is also important to other issues. Air quality is not a climate change thing. It's another book. Ocean acidification is related to climate change, but it's its own global change issue. So we've got a cascade of really important issues, including climate change, that we need skills to be able to deal with all of them. So I think, my recipe is relevance, transferable skills, in the 21st century. And I very much appreciate, I think one of the things that's going to help us in the next few years is going to corporate where they see the future of the economy that they're working towards. What they have to call for this work, and a lot of them are calling for the work at intersection between climate change and global change, relevant issues, transferable skills, 21st century. We need them to call that out. We've done it. Now they need to do it so that the education system responds accordingly at a commensurate system-wide response as opposed to early adopters. They're just, great teachers over here, 20 over there on the other side of the hall. Not so much. That's a long answer, but hopefully it works. Yes, please.
All right, so in the spirit of being interdisciplinary, I kind of want to ask you a question that links together the first talk with what you were talking about. Do you have, I'm Seamus Goldman from NAPTECA, and we're using technology to address a lot of these climate change issues through data visualization and innovative technology. So my question is there a way to use calm technology to create some sort of feedback that regular people would see all the time that would signal to them an interpretation of data? So it's kind of putting you on the spot, but it was something that just occurred to me is, what if we had a system of lights that just automatically triggered people to understand, sea level rise or understand air quality issues?
So this may not totally address what you're looking at, and I think there are a couple pieces of what Amber said that I really resonated with. Use the level of technology, the minimum level of technology needed, right? But there's another piece that is clear that when we look at adaptation responses and mitigation responses, and you ask communities, how much are we doing versus how much they are doing, whether they know it or not. So when you see a storm drain being worked on in your community, you have no idea that they took, stream precipitation projections into the size of those pipes, right? You just see a pipe, you see it in the hole, you don't know that that's twice the size of the previous one. And the reason why they're doing it is because they know that extreme flooding is going to happen. Same is true for IKEA, right? The roofs of IKEAs are covered with solar panels. So if you drive in the parking lot, you don't see them because they're on the top of the building, where they should be. You don't see them, so you have no idea that the transformation that's happening is actually occurring. Or that the building, I have no idea what's happening with electrons. Are they coming from renewable sources? Or are they coming from coal and nuclear? I have no idea. So a lot of solutions that are already underway are completely hidden to us, both on adaptation, mitigation. Climate change is that we're in polluted air. It's odorless, tasteless, and invisible, but it's still polluted. Thanks to EPA. But it's invisible. So making the transformations, both of the problem and the solution, visible through whatever mechanism, whether it's technology or not, is going to be a critical piece because it sets the new norm. If it feels like we're not making progress, why start? And we're already making tremendous progress, but most of that progress is hidden. Unless you drive an electric car, and I didn't see somebody in the parking lot. Mine is there, just jamming you. It's a great product. But my point is that a lot of the stuff is missing from what we experience and see. That's a really important concept. How you do it is, I think, you need to be more intentional. So, I'm not sure what this is going on here. One more question. Anybody? Either way, I'll be up. Brian, we're coming back.
Hopefully, this is a note on the bright point, despite what's happening this year. I mean, you said you didn't want to get into a political soapbox, and I'm not trying to do that either. But your mention of corporate, the role of corporate partners, actually, it's inspired this comment, it's more of a comment, but I'll let it get your reaction. So, as it turns out, Senator Whitehouse, Sheldon Whitehouse, this morning had a very good piece in the Washington Post. It was an editorial piece, but he talked about what's really behind the scenes in Congress, including people from both parties, and so I hate to say this, but I need to say this, otherwise I'm going to be talking in code. But the bottom line is not all Republicans are bad guys as far as climate goes. So it's a good piece because it reflects some of the things that I've heard talking to Capitol Hill staffers. But the encouraging point in that editorial from Senator Whitehouse is the corporate partners. He mentioned that, and that was how it will be closed out. And so, from your experiences with the climate negotiations and your experiences at the climate program office at NOAA, what has been what's been the total signal from the world in terms of supporting either explicitly or implicitly climate change education? Because actually that was called out in Senator Whitehouse's opportunities today, that the corporate guys may not necessarily run up and shout, "Yay, climate!" But if there's some quiet way that in which it can be done, they might actually get by.
So the two pieces of your question that really intrigue me. Part one is corporations are moving rapidly in this direction. They have already accepted our science. They've already interpreted it. They're already moving forward on adaptation responses and mitigation responses in bold, fast ways. They would like some stabilization in the market, the signal, but they're moving ahead independently. They know that that they're getting hammered by their infrastructure by climate change, and they know that they need to deal with the root cause through mitigation strategies. They get that. And they've been very vocal. So when I was in Paris, we were up in Le Bourget doing the negotiations, but down in Paris, my brother-in-law happens to be working in this field on the corporate side, and he was in meetings with corporate leaders and insurance company leaders worldwide in the City Hall of Paris, doing exactly what you're calling here. Right, so that's the hidden piece. The mayors, the cities, they're doing amazing work in this area. So, however, they're doing that, but they're not also making the social investments in the future workforce that is going to be critical to the multi-decadal transformation that they're calling for. So corporate are shirking their responsibilities, in my opinion, and I'm speaking as a person here, not as government, to help us make those social investments. I see education as a social investment toward an outcome that is a social good in the future. they're not also sitting at the table. We are going to be working this year through the Clean Network, supported by ESIP, to do exactly that. We need them at the table in combination with us. Government, local government, and also corporate, and then the NGO, university, college sector, informal education. We need to be sitting at the table in a much more unified way than currently doing. The cluster will afford us the opportunity to begin to build that structure and that approach. But they have got to start making those social investments with us, because we're not making it in the near term. One last thing I'll say about this is when I was asked to say, well, how much have we been doing in climate and global change education? And we have, in 2008, we started funding, and it went up around 2012, it peaked, and that's kind of tailing out at the end of this year. So there's a little bit of projects, but it's not anywhere near sufficient. It was about $140 million over that period of time, investment, federal and $7 million, that's it. Well, it turns out we've had 4 other spikes before. We've had a spike in the 70s, 80s, 90s, 2 in the 2000s, and then 1 in beyond 2000. So we've had these spikes. What we need is a plateau. We need to go spike up and then slowly plateau up. Because it's this undulated fluctuations of priority, non-priority, priority, non-priority, killing us. And we're not making the progress we need. So, and if federal priorities change, somebody's going to have to help us get to the between the spikes, fill in the gap between the spikes. Federal is going to play a key role here. And we have done it 5 times. We're going to come back again when the stars align again. But we need somebody to help us make the troughs a lot less low. It's like 0 now. I mean, but we're doing, the community is responding, but the dollars aren't. So it's kind of unfair to the community to ask them to continue to work pro bono. It's amazing. I love it. I take it and I enjoy it. But it's not fair to them to keep on doing it on the back of goodwill. So somebody's going to have to help fill it in. I'm sure that this is not a new concept for you guys in other domains. But anyway, I probably should stop there. Thank you very much for your time.
So just a few reminders that registration is at the bottom of the escalator. And then post reports are out there ready, for you to put up your poster between now and then afternoon break. Also, don't forget to check in the session in the item here /ESIP tab. And also, we're going to have a wonderful panel discussion at 11 o'clock for the data providers and also the disaster response to the community. So be back here at 11 break time. Enjoy the break and also reach out and network. Thanks.
He's trying to catch them. You guys have lots of pieces. No.
I have a very good friend who he started his own business. Like 2 years ago, my boss from his company, I was part of it. He's hiring people. And he said, I've been following you, man. So he's originally from Spain. So we are very interested in what you guys are doing. They told me that they are like this. So I want to give you, I mean, you probably know that, but it's kind of a piece of that. Yeah, no problem. So I told him that also Actually, the key point is with the guys. He told me he's now one thing that he said that he's data hiding people and they were only like we're looking for something like that to try to speed up the time to market. So have you noticed how also there's data campaigns trying to be the first that time to market. Now, one thing that I think is like kind of compared to that sometimes they are the last one to actually sleep with, they're gonna do it this right. Yeah, right, If you need I don't mind. Try to give you this one. And then like
So are they doing a panel next?
Yeah.
Yeah, okay. Let me show you something over here. Again, the book to a friend of mine.
Yes, good. And I tweeted yesterday and I shared your post.
I'm hanging close.
Oh, man.
Close to the.
Where are you?
Look, I'm right here.
All right. Perfect. So I'll sit right in front of you.
I'll be honest, like these things are in, there's no reason for this to be here, this is that. And that means as soon as you start getting more busy, now there's such downsides to the military system and then power down this whole I get it. So it's
Yeah, no.
Bring me down. I'm actually sitting down now. Yeah. Oh, yeah.
I'll be back.
Yes.
Hi, Eric. How are you doing?
No. I'm just going. I get some coffee.
Okay, guys, welcome back. Everybody can find their seat. We'll get started. And we'll let people go back in.
Good job.
Great. Well, thanks for coming back. So the second session is a continuation of focusing on this theme that we have of strengthening the ties between observation and user communities, and we're really focusing on a disaster use case and a disaster theme through this panel. And we have an interesting set of panelists coming from both data provider and user perspectives. And one of the things that people have said to me over the last several years is, we want more users at ESIP. We would like to have some end users. And that just keeps coming up over and over in the plenary or in the meeting survey responses. And so I'm really happy to say that on this panel, we have two real users. Wally and Mealiea, coming from the Edison Electric Institute, and Kari, Hicks, coming from Duke Energy, who are going to talk about their Earth observation needs. But before we get started directly into the panel, I also wanted to take this opportunity to share a little bit of work that's been going on in ESIP that we haven't heard a lot about. So first I wanted to start, this is background. So ESIP has been in this partnership with a group called the All Hazards Consortium, which is a lot like ESIP, but it's bringing together utility companies, the food sector, the fuel sector, telecom, all around their disaster-related and energy and information needs. And so it's been really interesting for me to get to participate in this group. And I gave a talk at one of their first workshops on data-driven decision-making, and I used this slide about why I care about data and information. And I started with this image, which is a hurricane coming up the coast of North Carolina in 1909. It was Hurricane Fran. But this wasn't really the data that I wanted to show. At first, I wanted to show this picture of my brother in our backyard when Fran hit our backyard. And so I thought I was telling the story about getting us all on the same page for, you know, I've been in a hurricane and you utility people have also been in hurricanes. But really what it turned out to be was a data story because I had this memory of the data on the picture on the left of my brother, and that was really hard to find. My mom couldn't find it. She thought it was lost. We'd sent it in the mail to my grandparents, so we didn't have it. Couldn't find it, couldn't access it, couldn't use it, even though I knew it existed. And the data on the right came from NOAA, and there's a web page for Fran with this animation. It was easy to find. I Googled it, I got the right date to put it into my presentation in a format that I could use. So, you know, I think we've really come a long way with earth science data and information. So this is, ESIP funds things called test beds, and we're going to start calling them incubators. But one of the incubators that we had was a collaboration between Storm Center Communications and the All Hazards Consortium, where we piloted using the technology GeoCollaborate. And this was something that we had no idea if it was going to work, and it turned out being a pretty epic success, I think we could say. And that's led to now wanting to be able to find from ESIP more data for these decision makers. And so we know that it exists, and it's how do we leverage the ESIP community to access resources that you all know about that we could then share with the utility companies or others that are looking for this data in real time and need to trust it. So the 3DM, the data-driven decision-making process, is to establish a work group. They have a trust framework that they're building. They're developing these use cases, and the use cases are really the glue between our community and these user communities, and then to validate and operationalize. And so we're going to have, this shows sort of more of that glue. We're going to have another workshop in January, at the end of January. And so if at the end of this panel you're interested in working more on this activity, I would really welcome conversations on this and to see if it's a direction that we want to take the ESIP community. So with that, I'm going to turn it over to this panel. And first, I'd like to introduce Frank Lindsay, who is a friend of ESIP and we know really well. Frank is a systems engineer at NASA Goddard and is going to talk about the American Customer Satisfaction Index survey. And Frank, I'm going to move this slide to you. Oh.
Hey everybody, it's good, so good to see so many familiar faces. So, I think the impetus for this talk, and it's good that it's leading it off, because, and I'll explain why, that I think there's some folks out there in the community who are interested in how we actually know what users want and how we go about taking that input and developing our systems in reaction to that. The disaster community, of course, being one. So I'm going to talk a little bit about that, and obviously the ladies and gentlemen here on this guys group, and specifically that as well. But hopefully, many of you aren't aware of some of the work that we actually do in that. All right. So user experiences we have found are not always ideal. I think this picture says a million words. There's a lot embedded in that picture. But this talk is going to be focused on that. How we want to help our users, their needs and their expectations, how we do that. So you can say, you know, we designed this beautiful pathway for you, and what user, what are you doing? You're taking a shortcut. You're willing to walk through the mud. You know, we've designed that. So we're trying to close that triangle between what the users actually want, how they want to get their data, and the systems and services that we actually design as well. So that's what I'm going to focus on. All right. So as this, and NASA gives this in just 4 bullets. The lion's share of folks are aware of the Earth Observing System data and information system. The very large system, you know, some 20 years old now, that supports earth sciences at NASA, backbone of that, of course, is our 12 discipline-oriented data centers, as well as an equal number of SIPs that do a lot of science data processing as well. So we initially, of course, those data centers, those DACs, being discipline focused, wanted to serve those user communities using a particular kind of data, instruments, data products, etc. But we also provide this backbone, this network that's able to ship around terabytes of data between the various highly distributed centers across the United States and internationally as well. But we also develop tools and services. Early on, it was known you can't just give somebody an HDF file necessarily. We really have to work with user communities to help them to lower that bar so they can actually use the products that they need. And lastly, we don't do this in a vacuum. It's a highly integrated data system that works nationally and internationally. So it's been quite successful in the last 20 years. All right, so some of those systems, we can learn some fairly generic things about our users, like where are the data being distributed? So in 2016, you can see that the lion's share is pretty much distributed internationally, not quite half here in the United States. That tells us something. It tells us about where these users are, the data products, and where these things are actually going. That's somewhat useful. However, this is a chart that I borrowed from Chris Venice, and he was the our data architect, and he was thinking about it, and he said, well, actually, we have all kinds of inputs from our users, and they range, the ACSI. So on the one hand, we have sample size. How many people are we actually engaging and talking to? And at the bottom, what are they telling us? Just a little bit, or are they really going into the weeds with us about what their user needs might be? And so we have this whole range. The ACSI, I'm going to talk about in just a second, is one of these where we have a very large amount, and we obviously can gather information from that. But if you go down, we also attend application workshops that have hundreds of people that are these conference encounters, AGU, etc. We have advisory groups that still provide information, UWGs that advise the DACs as well. They have input. And even all the way down to help tickets, where people are saying, this button does not work. So it's a gamut of information that we're actually taking in. In the webinar, and that feedback, I'm going to talk about at the very end. So keep this in mind as we walk through these. All right, what is this mysterious American Consumer Satisfaction Index, ACSI? Just that many of you, probably quite a few, have interacted with us on this survey, and this is a little background about that. How we use it. So this thing was developed at the University of Michigan, and it's a uniform national cross-industry measure of customer satisfaction. And so they deal with over 300 companies, 100 federal, local governments. So it is out there. It's been, and it is widely used as well. So it's a measure of customer satisfaction, but there's a predictive link. The secret sauce in this, in essence, is they're going to tell you how well you're doing in particular areas and what actions you may be able to take to increase your score, to increase that user satisfaction. We work with a company called CFI that happens to hold a patent to the modeling engine that actually denotes or actually derives that score. And again, as I said, one of the reasons why we like to use it is actionable. There's customer feedback, and we can actually look at our systems to see where we can tweak them to actually do a bit better. Oh, and by the way, back when we were reinventing government in the 90s, there was this act, PL 10362, the GPRA, I think it was Al Gore at the time, that wanted agencies to institute performance measurements. Just don't say, we're doing great. There should be an independent body out there looking at what government does, what industry does, and saying if you're actually doing. So for us, that is EOS-DISC is the project that manages EOS-DISC. We want that information for each of the DACs. We want to know how our data centers are doing, and we want to use this so that we can leverage things, activities go on the DAC so we can continuously, and that's why I underlined it here, continuously improve the service to its customers as well. And so for us, CFI, we broke it down into these 6 areas that I'll talk about in this next chart. So this is a cartoon of how they actually derive it. And again, since it's proprietary, it's basically a weighting scheme for these 6 areas on the left that they call satisfaction drivers, so product quality, selection, customer support, documentation, search, and delivery. And these are drivers that all, once scored, derived the index for this year was 77. And on the far right-hand side, they're giving you measures of if you change your score up, if you improve it, what is likely to impact. And that would be likelihood to recommend your service, as well as user services in the future that a person would use. And I have many skills. One of them is not survey methodology. So I put the link at the bottom. It's a fascinating PDF. It really goes into a lot of detail of how they derive that score without actually showing you the weight that they use. So if you're interested in that, rather deeply than that. So the general benchmarks, where do we fall? So for this year, EOS DIS, right next to that arrow there, is a 77. And we've done this for over 10 years now. And don't think of this as like a grading scheme like 100, 90, 80. We're just a C student. Not at all. I put others down here so you can see, like the overall federal government for 2015, because they haven't done theirs yet. It's a 64. We're significantly higher. And Jean Baker, who's one of our deputy project managers, she emailed me. We've been texting back and forth. And I want to bring this point up because I didn't know about this. We have a very large sample size, much larger than many of the bodies. We have over 7,000 respondents to the survey. It's quite a few. So for instance, if you looked at the rural development, that is based on maybe 50 to 70 respondents as well. So in fact, CFI likes dealing with this because our sample size is so much larger than a lot of the other groups on the federal side that they deal with as well. So you have to take our relative comparison here with a grain of salt. So, and if you're interested in this, you can go to the CFI website, and they, in real time, they're updating these things all the time across a variety of industries. It's fascinating stuff. But aside from that very general number, and again, we're doing that for GPRA, we're doing that for OMB, so that we have a independent body that's assessing how well we're doing based upon user feedback. But we've turned this thing around to actually be very useful. These are some of the areas that we also look at in the survey as well. Like what areas of earth science, and services are, folks coming from. Here for last year, 2/3 were, services for the land community, 28% for the atmosphere, 15% for the biosphere, etc. So when we're looking at our systems, we can tailor them more based upon our knowledge of where our community is coming from and where they're interested. We even did something on software packaging. What do you use alongside the data to actually get your research or application done as well? And over three quarters of them stated using some software tool packages as well. Very important, again, when you're making investments in your system. All right, one other thing. I'm going to go very quickly. All right, so we also pulled together, because remember, think of that range of things, the inputs that we're getting from all those sources. So last year we called together a user need technical interchange meeting, where we utilized information coming in from all the data centers, and we sat down for 2 days, and we wanted to sort, categorize these, do an assessment and prioritization. Because even if we get thousands of brilliant suggestions about what we might be doing, there's only limited funds to do so many. And again, since we're building the system to serve all of our sciences, not just like one particular segment. So this type of information prioritization is absolutely key. So we did a lot of whiteboarding. And this was the outcome. So this is on our wiki, and you can go look at it. The blue ones were those suggestions, those user needs that could really be handled technically by some of the groups that we have already working with Estes, but there's many others that do not. So this was if you've ever been on the panel on the final day, and you do a rack and stack of proposals to say, what is our consensus? What do we think is the top priority? What's the best one here? Similar format. And I must say that unlike herding a room full of cats, we really did get consensus across a very diverse group of data centers on what the top priorities. So one last slide really on social media, which is a whole other area. And just to let you know, since I'm running out of time, the communications team for Estes has a poster out there that has everything I've talked about here and a lot more. So so you can go into depth. But a couple things that we've really found that work very well are these webinars, where we have professionals from the community coming in, talking to other folks interested in data products, tools, etc. And these things have been wildly popular. And the reason why I put this in here is because because that is another incredibly valuable source of a user sitting down with you, going through some data product, and they can let you know what they do, what they don't like, what they need, or what they might not need as well. So as takeaways, very quickly, so we use all of these inputs to evolve the data system. We know we have more communities, we're gonna have more missions, we're gonna have more data products, so it's not gonna stop. So that's exceedingly important. We don't collect a bunch of data. So we have a whole variety of methods that I talked to you about as well. And we often collect way more than we can use. And in those instances, we use like mediating, knowledgeable people to help us understand disasters. And lastly, help us. So I've mentioned some here, but what are we missing? What are ways, means, meetings that you know of that we could actually get even more in? I'm going to hear some from the disaster community here that I'm really interested in doing. And that's it. Thank you all.
So next up we have Wally Mealiea from the Edison Electric Institute and multitasking. So Wally is from the Edison Electric Institute, and this is a fairly new association for me, but again, it's bringing together the utility companies, and we'll say a bit more about that. He serves as the manager for the business continuity group, and in this role, he supports their initiatives and programs and policies to improve the industry's response to major outages and maintain business operations. And this includes EEI's National Response Event Framework, the Spare Transformer Equipment Program, and the industry's Transformer Transportation Initiative and Cyber Mutual Assistance. So I'm really excited to hear him lay the groundwork for us on how the utility industry is working.
Thank you, Erin, and thank you everyone here for allowing us to come and speaking for the meeting. Typically when you start these presentations, you have the slide saying, here's who I am and where I'm from. I'm going to do that about a third or fourth just to shake things up. But I assume everyone here has electricity in their home, in their office, and that you all appreciate it and miss it when it's gone. Well, our member electric power companies are the same way. They appreciate it, and they appreciate the opportunity to deliver it to you because that makes them revenue. And they also work very hard to make sure when it inevitably does go out, because you all are earth science data experts, the earth is often our enemy. Most outages in the United States are caused by weather. There's a lot of discussion of things like Russian hacking, cyber attacks, and whatnot. But really, weather is the primary cause of outages in the U.S., including major outages. So while we appreciate Mother Earth, sometimes she does damage to our infrastructure. Before getting into some of the disaster response initiatives the industry has, I would be remiss in not pointing out that there are really several types of electricity providers in the United States. The largest number in terms of companies are publicly owned utilities. So these are, in colloquial terms, municipal utilities. So if you are from, say, Los Angeles or Orlando, Florida, Jacksonville, Florida, your electricity provider is owned by your city or, in some cases, county government. There are about 25% of the, in terms of numbers of providers, are cooperative utilities. So these are the rural electric cooperatives, many of which are not areas like suburban Atlanta. But that makes up about a little over 25% of the industry. And then my segment of this sector are investor-owned power companies. So these are privately owned, but publicly traded companies that reflect only about 6% in terms of pure numbers. However, our members have roughly 70% of the ultimate end users. So there are three pieces of the industry, and a lot of times when I'm on these panels, my colleagues from the associations that represent those other segments are here. But I'm going to try to do them a little bit of solid by noting some of their programs. But my point is that the industry is not necessarily monolithic in terms of the companies that and the entities that participate in it. However, we do tend to operate in similar fashions when it comes to disaster response. And increasingly, we are more aligned as we try to address perhaps very, very significant, large disasters, things like Superstorm Sandy or beyond. And I'll touch on some of those future threats in a little bit. So I represent Edison Electric Institute. We're in the middle there. Our members, as I said, are the shareholder-owned electric companies. There's another association, the American Home Power Association, that represents the municipal utilities, and the National Rural Electric Cooperative Association that represents cooperatives. And again, you can get some idea on numbers. There's about 2,000 munis. We have 67 holding company members at EEI. That makes up about 100 operating companies. And then there are about 900 cooperatives. So when we think of electric companies, there's obviously a lot of them out there. Here's our slide. This is EEI's membership. We're in all 50 states. As I said, we serve about 70% of ultimate customers. And the munis and co-ops are basically in the negative space, the white space. Not disparaging them, but just that's where they are. And you also note that those, with the exception of, say, big cities, particularly for the cooperatives, they tend to be in more rural areas, and that brings some incumbent challenges in both serving customers, particularly restoring customers. If your density is much less, it takes a lot more effort to, restore, say, 10 customers if there's 1 per mile rather than 10 per mile. So when the power goes out, basically all utilities work in roughly the same process. You go from big to small. First is you want to restore your power plants. If you can't make electricity, then load using entities obviously don't have their lights on. And then it sort of goes down into the transmission system. These are, if you think of the wires that you see out there, these are the big wires. The distribution system is the smaller wires that ultimately go to your home or business premises. Then substations are a critical component of the electric system. This is what either steps up or steps down electricity. For full disclosure, I'm not an electrical engineer, so if you have to talk about how electricity is made, I can give you a very high level. And then you get down into, so really you work on restoring the bulk system first, biggest bang for the buck. Then emergency providers, this could be hospitals, fire stations, perhaps emergency shelters. Most utilities have lists of these that they designate in advance by working with the local communities. We need to restore this hospital before that hospital, this fire station before that fire station. Other infrastructure entities, water pumping stations, perhaps some fuel stations. Then you move to basically large service areas, or what we call main feeders. That's generally the lines that go down a major road, and then ultimately the line that goes down to your house at the end of the road. You wonder why you're not getting power on day one and after the road. But the goal is to obviously do this first safely, but second efficiently. So I was at a meeting yesterday where a restoration expert from actually Kari's company, Duke Energy, noted that sometimes they will go in and restore, say, a feeder, and then they'll have to leave to go and fix another large feeder. People on that street might say, well, how come they didn't fix the hookup all the way to my house? But the main goal is to do that so there's the most bang for the buck. Now, electric companies are large entities, but they're not staffed for 100% coverage for disasters. So for 50, 60 years, really, probably since the beginning of the industry, this concept of mutual assistance or in the public power side, mutual aid has developed where companies basically voluntarily partner with each other to provide support in a disaster. And typically that's human capital. You need people to restore power, put up poles, string lines, and the like. So what mutual assistance does is multiplies the workforce for companies. If Pepco, the local utility here, was to say, we have a big ice storm, they might call on their neighbors close by and say, Baltimore, come out, we need 500 extra guys so we can restore people. So those processes have been going on for a long time. And the good thing about it is it's very flexible. Amongst our members at EEI, we have tried to design the system so it scales from local to regional to ultimately a national response. And I'll talk about that in a second. Now, all three of the segments of the electricity sector operate their mutual assistance process in sort of a similar way. So, and I won't go into details here, but it basically, again, thinks about concentric circles and regions scaling up to national. For our segment, we have what we call the National Response Event, which is where we try to coordinate all the resources at a national level, building up from our regional networks that run response during a typical emergency. As we look forward to future threats, coordinating with the government has really become very, very important. And the industry operates through the Electricity Subsector Coordinating Council. Coordinating councils were set up after 9/11, like DHS, and for all of the critical infrastructures. And the point here is that we look to try to build unity of effort, unity of message, particularly with federal partners, so that the industry can work in a combined and unified fashion with the federal government for disaster response. A little bit about the threat landscape, and this gets to some of the challenges we have going forward. My favorite on the high likelihood but relatively low consequence are friendly squirrel. Squirrels do actually cause a significantly large number of outages in the United States. And as you go across the bottom axis, obviously you get the things that people like to talk about, the scary stuff. Nuclear hazards, EMP, biological problems, basically acts of war. Those have immense consequences, but are actually very unlikely. So when you get to what are the data needs to help us safely and efficiently restore power, it comes down to, in my mind, sort of four broad areas, and I think Kari will probably be able to talk about how it's more directly used in the company, but you have geographic information. You have weather information, as weather is a huge impact on utilities. And that gets down into things like mapping, route planning. Restoration often requires movement of people for restoration of physical damage. And then finally, the cross-sector infrastructure awareness is an area that's become increasingly important because we are very interdependent with other sectors. Just as everyone relies on electricity, we rely on water, natural gas, which powers power plants, also liquid fuels. Our trucks run on diesel, obviously. The transportation sector, be it roads, rail, move heavy equipment. Finance is an interesting challenge in that if, say, the power's out for a long time, nobody pays their bill, the electric company doesn't have any money, how do they pay people to fix the system so they can start providing electricity to make money? Sort of unique challenges. And then ultimately, the communication networks. As the systems become more digital, we rely heavily on telecommunications to run the system and communicate, and those systems are often impacted adversely in a storm or other incident. So finally, there's a couple areas where we're really looking, I think, for potential opportunities. I don't know if anybody's talked about UASs yet. Drones are becoming incredibly useful for companies for damage assessment. And then thinking about GIS or really earth science data into some of the emergency tools and programs we have. We have some tools we've developed that support industry response, ramp up to allocate resources, the whole concept of mutual assistance, having good information during stressful times is so critical. How do we move spare equipment? And then finally, and I think this is where your organization can play a very valuable and vital role, is how do we coordinate our private sector with public sector data, and even private sector data, to try to make that decision making more impactful, to ultimately bring power back to customers. I think that's it.
Thank you so much, Wally. I think one of the last things you mentioned was about the long-term outages, and that was something that I had never crossed my mind, that we could be without power for a long time, or how that would affect us. So with that, the next speaker that we have is Kari Hicks, and Kari is coming from the Duke Energy Company, and she's a GIS specialist and a data analyst, and she also has experience working with remotely sensed data. So I'm really excited to have her here because I think she's going to give us sort of a boots on the ground understanding of how Duke Energy is using data. And at the end of all of these presentations, we're going to have time for questions. So I hope that, you know, as you're thinking of things, please jot them down, and then we'll come back and have a conversation.
So keeping with the sort of theme of facilitating that relationship between data users and data producers, I'm going to be going a little bit into the background of Duke Energy and what our data situation looks like in its current state. And I'm also going to be talking a little bit about sort of where we came from, how that's all changed and evolved in the last 20 years or so. And then some of the challenges that we face, particularly when it comes to disaster response, and I'll be using Hurricane Matthew as my case study for that. So the story of data at Duke, and that's kind of hard to read, but I'll read it to you, no worries. We have actually, over the last 10 years, acquired several rather large utilities. And as anybody who's been a part of a merger knows, when that happens, you get about 200 different ways of doing things all under one group. So back in 2006, we acquired Synergy, which was actually a merger in and of itself between the Cincinnati Gas and Electric Company and PSI. And that actually is where we extended into the Midwest. And we acquired Progress Energy in 2012, which allowed us to acquire significant land in Florida. And then most recently last year, we signed a deal to acquire Piedmont Natural Gas in North Carolina. So just kind of, talking about that situation where you have a lot of people doing things in very different ways, using different kinds of technology. We have people using Intergraph, or also known as GTEC. We have people using Esri to collect data and to do analysis. We have people using paper maps, and that's it. They don't have a GIS system yet. So we've been in the process in the last couple of years. There's a program called Enable. And the whole point of that was to bring everybody in the company under one umbrella, and everybody using the same software, ideally. That's kind of, a little more difficult than it sounds, and that is actually rolling out this year. So as of this year, everybody will be using the same technology, supposedly. Everybody will be doing things the exact same way, and it will be perfectly reasonable. So talking about what our data actually looks like, we actually are a little bit of a hybrid, in my mind, between a producer and a user. We actually produce quite a lot of data that doesn't go anywhere but stay internal. We don't share a lot of data, coming from the private sector, especially utility. We're very, very uncomfortable with sharing data, and I think that that's very slowly changing. But as far as external sources of data go, we actually use local municipalities and city governments for a lot of our land base. So the parcels, street center lines, right of way, A lot of that comes from external sources. And then we participate in a lot of data sharing and consortium. So I'm actually on the board of IGIC, which is the Indiana GIS Council, and also CAGIS, which is the Cincinnati Area GIS. So those are organizations that are meant to bring data sharing together, and we work a lot with them to sort of, we share some of our data, and they provide us with really, really good quality data as well. We use a lot of external services, and I'll talk a little bit about that when I talk about Hurricane Matthew. But we, can't thank organizations like NOAA and the National Weather Service enough for providing those awesome rest services, because sometimes, when it comes to a disaster, you don't know what you need until you need it right now. And that was definitely the case with Matthew. So we use a lot of those services, especially during storms. And then we contract a lot of our data. So we may pay a third-party company to go out and collect GPS coordinates of manholes in Cincinnati, for example. And we actually purchase a lot of exclusive rights to data. I think that's kind of been the norm for a long time in the private sector. I think that's changing as well. And lastly, we do use some remotely sensed data like LiDAR, but that's particularly common with transmission and vegetation. And I'm more on the distribution side, so we haven't quite ventured into that on my end of things as much. And we would love nothing more than to use drones, but that's not happening yet. So crossing my fingers. Internally, our primary GIS data store is Small World. So some of you may have heard of that is where 99% of our GIS data comes from. We also use Maximo for customer data, for work management as well. We have a lot of AutoCAD and MicroStation going on, especially for what we call internal world. So internal to the substation or inside of the switchgear, we really have to use non-spatial diagrams to model that. And we have thousands of databases roaming around out there that we really haven't corralled together yet. So we've got, Oracle spatial databases and SQL Server databases that they're just kind of operating on their own. So we're working on getting that together. And paper. So it was only 5 years ago that the Midwest GIS, that's the organization that I'm a part of, was formed. And we had boxes and boxes of work orders and maps and just paper information that had not made its way to our GIS system. So the last couple of years has been spent really focusing on getting all of our data actually accounted for, and I'm sure that there's some. So it's an ongoing process. And it's just a quick little image that shows kind of how our Small World Aegis system actually is the hub of all of the GIS data at the company. It feeds everything from Maximo, which is our project management system, Call Before You Dig, which, more Call Before You Dig, because we're out there. DMS, which is our outage management system, CMS, which is our customer management system. So it's really where all of that data comes from, is from Small World. So I feel like in a lot of organizations and companies, their GIS evolves in a similar fashion. And it tends to start with paper records, which for us it certainly did. And that tends to migrate to non-spatial technology like AutoCAD and MicroStation, which then slowly sort of evolves into spatial data. So you progress it with Small World. For many others, it's Esri or a similar sort of structure. And then eventually, after some time, you get into an integrated or enterprise GIS structure. And, it's not exactly linear, obviously. I kind of simplified it. And for us in particular, we're still kind of going through all of these and sort of each step every day. You can kind of model it that way. But what I find really interesting is after you get to that point, once you have that integrated enterprise GIS, all the data is in the same place, everybody can access it, it's awesome. Then what? How do you take it to the next level? How do you make it even better? Like, how do you make your geography work for you? And, I would think that we're probably in this area right here, especially after the Niepold has been deployed. But I'd like to get further into that question mark very soon. So once you get to that question mark point, then you start sending your people at conferences, and they start getting a lot of cool ideas. And you hear buzzwords like, the Internet of Things, putting sensors in people's PPE when they go out so we can track them everywhere they go. Or, real-time data. You may have heard of the Esri's, geo event extension, being able to have real-time data or updated, every couple of minutes, has become really important. Or big data, that's another buzzword. Once you get enough data, there's some really interesting analysis you can do with it. And cloud storage. It's important for me to mention cloud storage because, we've all been an Amazon server and how amazing cloud technology has become. But for a lot of companies, that's just not an option currently, and Duke Energy is certainly one of those companies. We are very, very hesitant to store data in the cloud for security reasons, but I think that's slowly starting to change, and we're starting to become a little more open-minded. But, it's definitely a slow process to get to that point. But what's really missing from all of those is this idea of collaboration. So I'm actually working with GeoCollaborate as well on sort of a test project to see if we can't bring all of that data together in a way that allows people to sit down and work together in a virtual environment to make geospatially informed decisions. And I think once you have an enterprise GIS, it's integrated, it's all in one place, the natural next step would be to create sort of a virtual meeting space where that data all comes together. People can make decisions in real time based on relevant information. To kind of bring all that together, I'm going to talk about our experience with Hurricane Matthew. I'm sure everybody knows about Hurricane Matthew, but in case anybody was living under a rock at that point, Hurricane Matthew was a hurricane that hit Florida and the Carolinas last October, and Duke Energy had about 1 million people without power immediately following the hurricane. And they originally forecast that Florida would get the brunt of the hit, but it ended up being actually Georgia and the Carolinas that got the worst of it. And we had massive flooding damage, especially on the western side of North Carolina from storm surge and rain. And it was so bad that we had entire substations submerged, which are not good for them. You don't want substations underwater, that's never a good thing. So when we have a situation like a disaster or a storm, oftentimes employees like myself will be put under storm duty, which basically means your life belongs to the storm until otherwise noted. I'll go into what's called a war room. So this is not what our war room looks like, but I like to, it kind of represents the feel, what it feels like. And traditionally, when these situations arose, whether it's a small outage or a large one, everybody would crowd together in a room, people would print off maps and put them on the wall and put them on the table and mark them up, and we deploy people out to start restoring power. The problem with that is with paper maps, as you can imagine, you are not getting the most recent data that you can possibly get. You don't know exactly what the weather's doing, you don't know what the floodwaters might be doing, and you don't know exactly who is out. For a long time, if a customer didn't call in to say, I don't have power, we didn't know about it. It wasn't automatic, and in areas it still isn't automatic. So when Hurricane Matthew hit, we all crowded in a conference room in Cincinnati, supporting from a remote location. And I mentioned earlier a program that we have called MyWorld. So it's developed by UniSense, it's a web application. It brings together all of our Aegis data in one place to be viewed. And we initially said, well, why don't you guys use MyWorld? You've got this great application. This was, being a company to create this for you. But it ended up turning out that it wasn't exactly what we needed. The biggest problems with it really centered on the fact that it wasn't interactive in the way that we needed it. It wasn't real time. It didn't have routing information. We had routing mentioned earlier. That's very important. We had road closures all over North Carolina. So a 30-minute drive might turn into a 4-hour drive. And in some cases they did. And it just didn't have exactly what we needed. So in response, our group created a web app, and it was simple. It was just using ArcGIS's web app builder, and it incorporated routing, which used real-time traffic data from Esri's traffic service. We incorporated live weather information, as well as flood modeling from NOAA, which was an absolute lifesaver. It allowed us to predict where the floodwaters were going to rise and where they were going to sink, which was really important for planning, where we were going to deploy people. And it ended up being a huge success. And it turned out that a lot of people in our company weren't really aware of our GIS. They didn't know what it's capable of. But
but when that application got sent out there, people started using it, they, oh, wow, oh, okay, that's really neat. So it ended up almost being kind of unintentional advertising for our GIS system. And once that happened, people came back and said, hey, can we do that with this other thing? Or can we start preparing other applications like that for outages or for deployment of crews? And it really sort of put that out there. So this was the actual war room. This was in Raleigh, and you can see there's actual paper maps printed out surrounding that map there. We included a custom printed out with our app. People could print whatever size they needed, and it ended up being very, very successful. That's the web app. I can't show it to you, unfortunately, but I can show you a screenshot. So lessons learned from Matthew. We are almost at integration. I should have put an asterisk there, but not collaboration yet. So that's something that I think is going to be the next step to bring our GIS to the next level. We have a real need for real-time data, and that's really critical for storm situations or other disasters. And most importantly, I think flexibility and agility. We need data now. If there's a situation where we need something, we may not anticipate that until that situation has arisen. So, having that ability, all of you work with data, you come from organizations that produce data, so having that agility and flexibility is very important. And lastly, real-time analytics. So being able to do that floodwater analysis to say, floodwaters are going to rise here is very, very important. And that's all I have.
Thanks so much, Kari. I think that you've really you set the panel up into one of your slides, because I think where we are now is we've heard from Frank about user feedback at NASA, and then we've heard from 2 users, and I think where the next 2 panelists go is really into this question mark of what do we do when we have our own systems. And so I'm really delighted to introduce Rich Frazier, who's a technical advisor for the FGDC, Federal Geographic Data Committee Secretariat, and he leads and supports the National Spatial Data Infrastructure, and we ran across Rich's work when we were at GEO in November, and so I'm really happy that he's here to talk about the Mealiea data platform that he's working on.
So thank you, Erin, for the introduction. Appreciate it. One of my duties and responsibilities is to support the USGEO efforts on developing the Mealiea community platform. So I'm pleased to be with you today, and I'm very passionate about this, so I'm going to try really hard to stay within the 10-minute threshold that has been assigned. So a little bit about the Mealiea effort, just to start out. It's a capacity building effort to enable the user community. It is composed of the Americas Caucus within GEO. There are 16 countries that are currently part of that caucus. We have several observers from other countries that we hope that will join the effort long term as well. So the Mealiea community platform, it's a regional community effort. It's a resource to promote collaboration and coordination amongst the GEO members in the Americas. We hope that the community platform, which is a user-driven effort, is one of the key principles that we have established as part of the community's goals and objectives, is to be a resource to share, find, discover, learn, and participate in coordination of Earth observations and the usability of Earth observations, working with various providers within the community. So what you see here, this graphic up top, really speaks to a lot of the user requirements and the feedback that we've received so far. And I'll talk to that more so in terms of the platform itself and what some of the expectations are. So as you look at this, one of the first things that the community established from more of a business context is what are those thematic communities that we'll focus on as priorities. And they are within the agriculture, disasters, water, and biodiversity domains. In terms of requirements, the users identified 5 key areas. They needed data, they needed tools to exploit the data, they needed products that can help interpret the data, and services and resources that would allow them to use these data efficiently. As part of the data domain and resource requirements, they want to be able to find, get, and use social, economic, and environmental data, along with the Earth observation data, to provide understanding and decision-making for the various stakeholders. The data within a data domain, we endeavor to set up a catalog for data access, data resources, that the community will be able to share, publish, and manage the data and use data from the various providers. That we will be able to search the data across many different dimensions and within many different contexts and groupings. And most importantly within the community, the goal of co-creation, curation, harmonizing, and being able to enrich and tag that data so that it can be used efficiently amongst the stakeholders. Over on the right here, you see a little bit of what I'll talk a little bit more about the data hub that has come out of this initiative. And I'll also just really set the stage that this is a prototype and pilot initiative that we hope that will go into operation in 2017. So this initiative kicked off in 2016. We've been working through these activities based upon the user requirements over the past 6 months. The next key area is tools, and one of the key areas in terms of the stakeholders is being able to take the data, use the data to synthesize the information, and have the analytical tools and so forth that will support their ability to create the products that are necessary to support understanding and decision making. One of the key findings through a research effort that we have done with them is that there is a lot of data out there, but there aren't a lot of tools to bring that data together, to assimilate that data, to determine authoritative data sources and resources and so forth as part of their ability to create the products that are necessary to support decision makers. That they need to be able to have the ability to visualize that data and model the data and resources efficiently and effectively. So we've identified, working with that community, a number of different needs and resources that are necessary to support their abilities and capabilities to support the various co-created products, because it's not just looking at the US specifically, but it will be looking across the entire region as well. You see some of those tools here, just kind of flashing here on the right-hand side, and one of the key principles that we identified as well is not to reinvent the wheel, to take advantage of the resources that are out there from the providers wherever possible, and then work towards integrating those resources and aggregating those resources where possible to support the community. In terms of products, the idea that as these products are being created within the community or being shared within the community, that these resources will be made available to the entire community across the Americas, and that as the communities work together, which is within each of these thematic areas, that these products and services will be made available within the community in a dynamic context that they can help work towards developing these, whether it's a disaster, whether it's just for general use or purposes, or other needs. You see some of these again on the right-hand side, when you see the flashing, that's basically what we're trying to show here. Some of the services that have been identified within the community that is needed, I hope you all are familiar with some of these terms, but like GeoNetcast, having access to satellite data and information, having access to training resources, workshops, alerts and notifications, and so forth. So this is just a summary highlight of some of those user needs that have been identified and how we hope that community platform will be able to support those user needs. And again, we're working very closely with those various user communities within each of the thematic focus areas. There are thematic needs that have been assigned for each of those thematic areas. Lastly, just in the context of resources, the community is hoping for some of the basic things that are necessary in the way of news, social media resources, community calendars, collaboration tools as a firm foundation to be able to collaborate and do the co-creation and so forth. In terms of a user-driven resource, this kind of gives you a context of what we've been doing from a capacity building standpoint in terms of the user-driven framework. We engage the users as one of the first foundations, first through building partnerships with the various communities that are already established, where we can take advantage of those communities that have been established. We try to use those first, rather than reinventing the wheel and restarting the process. You see some of the partnerships we've started with some of the initiatives in GEO, like GeoBond, GeoGlam, GeoGlows, Disasters Initiative within GEO, and others. In engaging the users, we've been doing needs assessments and conducted quite a few of those with the community in terms of what their needs are. And what you see here in the center more is what are those outputs. That's how we determine the data, tools, products, services, etc. Within each of those domains, there are key areas or principles or ideas of what their expectations were. So this kind of gives you more of a snapshot of everything you saw in the previous frames. So in 2016, we established the platform data as a foundation. We focused on and we developed the prototype data hub. We developed some of the visualization tools and services that they were seeking, and we established the community capabilities of the foundation as part of the pilot and prototype. In 2017, we'll be focusing more on outreach and education, data sharing, thematic data and tools, and some use cases. That's one of the key things we want to do in 2017 is some use cases to identify the key data sets that are needed. We determine some of that data into products and services for decision making, and we hope to be able to present those as part of the GEO Plenary this year, which will be hosted in the US, by the way. This is our architecture. Don't want to scare you because I know that can be overwhelming when people say architecture, it's very technical. But just to know, these are some of how we translated the user requirements from some of the key stakeholders. We've identified 5 key stakeholder groups from the user-driven analysis that we've been doing with that community. We've identified some of the features, functions, and services that are needed, some of the analytics and so forth that are expected. And we're using an open source CCAN, I hope you all are familiar with CCAN, as an open source resource to be able to bring those resources together from the various providers and share those within the community. We're linking national capabilities, regional capabilities, and global capabilities in terms of being able to provide these resources. We're tapping national resources very available. Many of the national entities already use CCAN, which is great. And I would encourage you all, if you are a US constituent, to register your data and information with data.gov. But we're working with all of the other countries to do very similarly, and we're bringing those together within the Emergeos community platform. We have developed and implemented several data and visualization tools. One of the things that we've been doing as part of the Emergeos initiative, because we have a number of areas where they have limitations in technology and so forth, is we bring the data to them. We bring the resources to them, the visualization, the analytics, and so forth, within the community platform, so they don't have to go out and find those things. And that way, if they need to just pull the data in a mobile context, they can pull it for an offline resource as well. We've implemented over 40 different data explorers, viewers, and analytical resources that will be engaged, and our inventory continues to increase as providers identify resources that they have that can support. So that pretty much wraps up, in terms of a context of all the different things that we're trying to do in terms of the platform itself, and it continues to evolve. And we hope that we actually have a website where it's online. I will share that with Erin so that she can send that out to everyone if you're interested in taking a look at it. You will not be able to see the data hub because that's something that the community asks us to keep right now as opposed to until there's a formal.
Thanks, Rich. Really great work, and I think exciting to see how it progresses this year. So our last speaker is Christoph Aubrecht from the World Bank, and he's seconded from ESIP. And I actually just met Christoph in the last week. Thanks to Sudhir, this is a nice community for making connections. And so I think where Christoph comes from is that the World Bank has been piloting using ESIP data in their programs, and they've realized that it's really useful and really successful. And so now they have they're going to operational models for that. So Christoph is going to talk about that.
Thanks, Erin, for the introduction, for the last minute invitation. So, I'm glad to be here. I'm really a very hybrid between the user and the provider here. From the provider side, ESA, and the user at the World Bank. But as we are running late a little bit, I should maybe just use a second slide, and then at the end you can see So, okay, so I'm seconded from the Director of Earth Observation Programs of the European Space Agency to the World Bank, and I'm coordinating all the collaborative activities that are going on between the two institutions. And mostly this is about an initiative we call Earth Observation for Sustainable Development. And I'll go a little bit more details on that. I wanted to show this, and it actually included sound. I wanted to wake everybody up, including myself, as I'm a little jet lagged. But there's no sound. So anyway, it's still a nice illustration. So why am I showing it? Not only to wake everybody up, but it's sometimes very difficult to communicate in user communities, and especially in an environment like the World Bank. How to use Earth observation. For them, it's rocket science, and they just want to don't touch it. It's too complicated. But it's really not like this anymore nowadays, right? And we try to promote the use of Earth observation data of analytics, spatial analytics in general, in World Bank operations, and slowly we are getting there. Very brief about this is the Earth observation program of ESA. Most recently, the Copernicus program in collaboration with the European Commission includes the Sentinel family, which is probably at the moment the most advanced Earth observation program, and probably more NASA people in here than ESA people. So I still keep that statement. Yeah, it's fun. It's obviously a lot of collaboration. This illustration shows the paradigm shift that we are basically in at the moment, and other also commercial providers like Planet and others very much touch this aspect of the space and time. That both spatial resolution and temporal resolution are important, and the Sentinels, in that sense, address it by having a twin constellation in the same orbit, just 180 degrees phase, so we have to cut the visit time in half and still keep a pretty high resolution. So this is very important for a lot of aspects in the World Bank, be it agriculture, be it flood, whatever disasters, to still have both sides of the ESA and the bank have worked together for quite a couple of years already, started in 2008. We had a lot of small-scale demonstration projects about the use of Earth observation data and services in World Bank operations. We also worked with other international financial institutions. But at some point, we really came to the conclusion it's enough. The value has been demonstrated. We now need to scale it up. And so in Paris, at the climate conference, ESA and the World Bank signed a new MOU at highest senior management level, and we now work strategically together on not small-scale projects anymore, but large-scale engagement. And we did the same with the Asian Development Bank just last year. A few examples of those projects, land use, land cover information and dynamics. We helped the World Bank build their data platform called Puma, where they put all the urban data, urban spatial data on, archive it, and facilitate access to it. We also, together with some World Bank funding, the German Space Agency developed that global high-resolution built-up area product, footprint it's called. Detection and characterization of informal settlements, also important in a disaster context, as you need to classify different types of exposure in urban settings. Landslide inventory mapping, flood mapping, climate risk mitigation. So we really address the entire portfolio of sustainable development in our engagement in the sustainable development community. The longer-term vision, so what we are working on right now, is an initiative called Earth Observation for Sustainable Development, and we really try to mainstream and transfer Earth observation into the operational working processes and workflow of the World Bank and international development in general. And well, the idea is to really show that Earth observation can be a best practice source of environmental information for a lot of work that is done. We have 10 thematic priority areas identified, 3 of which we are this year. And all of this is also integrated in the overall framework of UN and global sustainable development. Basically, further how this implementation looks like. We have two phases. So every thematic cluster is 3 years, where ESIP provides funding for an expert consortium of partners, mostly from the European Earth Observation Service industry, to engage with the banks. Phase 1 is really about strategic planning and stakeholder engagement. So we don't only want to provide them data. So all the ESA data is free anyway, but we really want to go further down the value chain and engage with the clients and the users. And what is a user in a World Bank context? It's a country, right? So the client of World Bank is a country. So your first entry point is Ministry of Finance, and then you somehow get down the line. So we try to also train those countries, the respective authorities in the countries, in using the tools that are developed, so that once the World Bank gets out, and once the projects are done, these countries can still keep using the tools. This is just an example of the urban project, urban development cluster that we are currently that's ongoing. So we have projects all over the globe, basically, where we engage, and these have been selected strategically with the respective leadership teams in the international financial institutions. I'm with the World Bank and also part of the development bank work. As I said, it's really not about data, but still data is the first aspect, obviously. So we need to promote data literacy. We need to get away from World Bank people believing that this is just rocket science. So first of all, we need to facilitate easy and most efficient data access, right? ESA, as an example, I just put the Sentinel Scientific Data Hub, where anybody can go and access and download the data. We also, as we just saw with Geo, we are quite strongly engaged with Geo. For example, we hosted co-developed the Geo portal that's just starting to run now. There's not too much data on yet, but I found one example where you can visualize Sentinel data. And after accessing the data, it's really about exploiting the data, especially in the user context. This is the most important thing. So it's not about the data; it's about analytical services and about understanding and deriving additional knowledge. And we have a concept at ESA that we call thematic exploitation platforms. Read to Google tabs, so you will find we have tabs on several domains. And as this is a disaster panel, so I put the geohazards tab. And what is this tab about? It's really about facilitating access to data, but also getting a user community of a specific domain together. So there's a forum there, and plus analytical capabilities. So you can produce you can put your tools up there, you can develop your tools, you can process on the cloud, you can download end products. We also try to address different levels of users. So from the expert user to the very, very basic user who still wants to push a button, but actually doesn't know which parameters to adjust. So we try to address the user community in different levels of the graph. Yeah, this is just a screenshot of how these toolboxes look like at the basic level. And if you are registered as the highest level user, you can actually adjust the actual tool. Well, I leave it to that. I just want to say, really, it's about, especially in the disaster community, because now this is a very different user community than the utility companies, and I tried to make some connection, and I found it when actually during my time at NOAA, we were using nighttime lights data that you see here for power outage detection, and we worked closely with the Florida company at that time. And so Earth observation data really can help in almost every aspect and every phase of disaster risk management cycle. And at that time, it enabled us to actually identify the power outage areas in the night after the disaster. So Earth observation can be very useful in many aspects. And once you identify and detect it, then you can measure it quantitatively, and communicate it to the user and try to address the challenge afterwards. So I guess that's what this is all about. And I look forward to the discussion.
Thank you so much to all of our panelists. And Jeff is at the mic, so this is the time. I'd really like to open it up to all of you, both for questions and comments and feedback to the panel. Jeff, take it away.
Great, thank you all for a very good panel. My name is Jeff with NOAA. My question is especially to Wally and Kari. You mentioned weather as sort of the biggest cause of outages. Well, the even bigger potential cause of outages is space weather, or geomagnetic disturbances, as they're called in your slide, Wally. And as you probably know, if we were to have a major solar storm event, we could knock out the entire grid on a continental scale, essentially, destroying the large transformers, which take a long time to build, that we don't have a big supply of, and that are often supplied by other nations now, as I understand. So we could be out of power for months, years, maybe. So that's terrible. But the good news is, if you know the solar storm is coming, perhaps because you listen to the NOAA Space Weather Prediction Center, you can just do an orderly shutdown of the grid and let it all wash over you in the dark for a while, and just turn everything back on. That's great. So my question is, I guess, two-part. What are the utilities, yours, and more generally, doing to really be sure we are totally ready to shut things down in an orderly way and that it actually works? And then, do you need anything from NOAA, the Space Weather Prediction Center, in terms of better data, better anything to help with that?
Great question. One, the utility industry does actually have NERC standards for GMD disruptions. So the industry is fairly well positioned and is obviously cognizant of the challenge. People often conflate GMD and EMP, and that's a big mistake because GMD impacts are obviously better understood. There's a little bit of predictability. You have to do everything at the speed of light, so you get what, about 8 minutes, maybe. Actually, you probably have more. There's also been a lot of attention to this from the federal government. There is standards and I guess an executive order to look at this as well as an EMP. So I think the industry is certainly, it's hard to be perfectly positioned against these types of challenges. Just to reassure everyone, a couple things. Actually, we are pretty well positioned in terms of spare equipment. Didn't get into that, but that's been a huge focus of mine personally over the past couple of years. But to your point, any information that can be given in advance, and I think this will become actually even more critical because the transportation bill that passed Congress last year, the FAST Act, it gives authority to the Secretary of Energy to order emergency actions for grid security disasters. And one of the disasters that is specifically noted is GMD. So I expect there will be greater, I know the DOE is already working with partners like Edison and NOAA. My expectation is that will continue to be advanced. And any early warning, obviously, the better it is because which presumably from an intentional act, probably a nation state, with GMD, you have some advanced warning. The waves are different, the impact is obviously a bit different. But the ability to understand that it's coming, any predictive advances are certainly critical to being able to, it's not quite as easy as just turning the dial to off, but anything we can go to try to basically disconnect the system. And there's also been a lot of advances on protection devices, which is probably the biggest focus is put something into Facebook. So, but the predictive data would be probably the key, as best you can.
Great. Kari, anything to add to that?
Sure, I'll just add that, just speaking from Duke Energy's perspective, our efforts to really modernize the grid, I think will be really important for strange calamities like that, just because right now, so much of our equipment is on the older side, so we're investing, billions of dollars all over the Midwest. The Carolinas are pretty much the part. But once, we're at a point where our grid is up to a modern standard, it will be much easier to respond to a situation like that. And then secondly, we actually have a group of meteorologists that work for Duke. We have our own meteorology department, so they have their eyes on the sky 24/7 in case of situations like this or large storms. So we're always kind of keeping an eye out.
I'm going to ask the panelists to keep it kind of brief too. Everybody keep it kind of brief just so we can get through. Brian.
Brian B. from Neptune and Company. So this question has especially, it bears a little bit of similar resemblance of Jeff's question, and the question goes to offline preparedness, as in, so speaking of the World Bank, right, the World Bank, GFDRR, the Global Facility on Disaster Reduction and Recovery, is actually prepared to have data sets available for deployment, like on laptops to countries like Haiti, where if anything goes wrong, you cannot depend on connectivity, because we had mentioned real-time data being important. So notwithstanding the fact that real-time data is important for you to find out what's happening on the ground, the question goes to preparedness and offline capability. So what in terms of preparedness for offline data capability is being done to cater for the fact that you might have severe outages that last for months, or you might have you would sometimes have data which you think might need to run predictive services over the web, but that assumes connectivity. So the question is, at headquarters, is connectivity and a big consideration when a disaster hits? And the same question can be asked of your crews that you might deploy from another state to another state. Do they need connectivity on the ground to respond? And if connectivity is an issue, how do you prepare small critical data sets ahead of these events so that you can operate even if the power grid is out for months or weeks?
So I definitely know from an IT perspective that, well, for starters, I'll say that our crews have offline and online capabilities on their tablets. So all of the data that we have available to them through their application is available offline. The only challenge with that is that you run into situations where syncing might become an issue, especially if you're doing any editing. But they do have that copy of the data always available. And then from a wider scale, broader scale perspective, we do, keep copies of data all the time. We have, central servers that continuously run that sort of make archives of our data. So in the case of a broad outage that lasted for a long time, we wouldn't be without any data. So I don't know if that answers the question.
And I wonder if, Christoph, do you have anything to add from World Bank?
Yeah, actually I do. So before I took on my position at ESA, I was actually leading a spatial analytics team at the World Bank, working mostly on country disaster risk profiles development. And the work in Haiti, you mentioned the GFDRI, goes a little bit into that direction. So having data of a pre-event phase is obviously very important, but it certainly doesn't replace the actual real-time data, because what the pre-event data tells you is, you can use it to estimate or to assess the potential damage given the pre-event status, because you know the affected areas and you know the exposure there, you know the asset values. You can come up with a first ballpark figure of where you want to put your resources. So for this one, it's really important because you can start right off right So it's extremely valuable to have the pre-event data. But at the same time, to then address the actual situation in disaster, you certainly need to have the constant data flow coming. And remote sensing data is good in a way that it provides you a constant data flow, but it's also tricky in a way that, especially if you mention Haiti and other tropical countries with the hurricanes, and so it's always cloudy, so you can't use the optical data, you need to use the radar data. You may deploy some drones, whatever, but you need to really adjust to circumstances and use the real-time data as well in combination with the real-time data. That's what I would do.
Hi, Steve Young, retired EPA. Thanks, Wally and Kari, for coming from the industry and speaking to us. Jeff kind of anticipated my question, but I'd like to refocus it a little bit and just kind of ask how prepared industry is to ingest real-time warning type data, like the space weather data. And the other example I wanted to throw out, I assume for storms, it's very sophisticated. Having a hurricane or a derecho or some weather event like that. The other example would be earthquakes. And that little window between the initiation of a major earthquake and when the waves hit a particular location. So my limited understanding is that there may be some things you can do during what might be, anywhere from a few seconds to several minutes that will help to minimize damage to the system. So I guess how ready are you to respond to quick turnaround warning data, and is there anything we can do to help you in that arena?
Well, on the second question, yes, I'm, and I'll defer to Kari to talk specifically about company. But I think there's no doubt that better collaboration with data providers and collectors and industry for these sorts of truly catastrophic type incidences would be helpful. I think that companies in geographies, so companies obviously on the West Coast focus a lot more on, say, earthquakes than hurricanes, which is more prevalent on the East Coast. The challenge, I think, is, what are some ways to connect the right people and right organizations so that the information can then be actionable. And that, some of the activities that Tom Moran's doing through All Hazards Consortium is focused on that very challenge of, there's a lot of data out there, and how do you get it in a way that, an industry can operate quickly. I think specifically the industry is certainly getting better and stronger at that. Are we in a perfect place for these, high impact low frequency events? Honestly, probably not. I think our industry is in many ways better situated than many other infrastructure industries because of things like some of the NERC standards. These are the reliability standards that the industry has to follow. And those include penalties if you don't follow them. So they have, there's a stick behind it. If you don't. But I think there's, on that slide of sort of the challenges or the threats that you face, it's an issue of calibrating for the things that are on the far end that if they happen, it'll be really bad. But, how do you put the resources also to the things that are far more common? Not advocating eradicating squirrels. The issue of that balance is a real challenge that good information can help make a little easier.
And I'll revert back to my previous comment about modernization because I think that investment is critical. Right now, if you want to open or close a switch, most of the time you have to physically go out in the field and you have to open that switch. So if there is a high impact low frequency event that we only have 8 minutes to prepare for, I can't tell you that we would be able to shut anything down or do something like that in a lot of areas because it It's just not up to that standard yet. But that, again, is why so much money is being invested to do that. Pretty soon, in the next 10 or 15 years, you'll be able to do all of that from the operating center, the distribution control center. So I think that and also installing communication nodes on a lot of our equipment is really important so that we have live information on what is actually being fed through a piece of equipment. But that's kind of a work in progress. But like it was mentioned, we're really more focused on the high frequency sort of problematic things that happen all the time, like hurricanes and storms and squirrels, because those are really the things that can impact our customers on a daily basis. We have our eye on those rare occurrences.
Great. We're running just a little bit late, but Anna, I'm going to get to your question and we can just be brief here. We'll wrap it up and we'll get to lunch.
Okay. I'm speaking in a, okay, so this is a response to your statement of the Earth is our enemy. And I was just wondering, it got me thinking, and I'm wondering, especially in the energy sectors, how you're using the observations that the sciences are providing to see if you can build different ways of providing energy in emergencies.
Sure. That's a really great question and something that I think about a lot. So Duke Energy is starting to invest a lot of money in solar. That's something that's happened in the last 2 years. But something that we're really having a challenge with is when it comes to reliability. It's a hard thing to move on from things like natural gas and coal because we have such a distribution of power available for that. So if there's an outage and we need backup generators, we need backup power, it's hard to get past that stage of using fossil fuels. But it's definitely something that has become really important at our company here recently, especially in the wake of the coal ash disaster that happened in North Carolina. Our company's become much more environmentally focused. That would be my answer. The Earth is definitely not the enemy, it's a friend.
Yeah, in retrospect, thinking, okay, here's the industry guys on the internet. Let me retract that. But just to echo on what Kari said is that there is no doubt that this industry, in the 20 years I've been involved, has evolved dramatically in terms of the generation sources and what pollution they put out. And notwithstanding some of the political changes, I think the economics and the reality of where the energy industry, at least on the electric side, is moving away from traditional fossil fuels, which coal, to natural gas that has grown dramatically. There are some, obviously, environmental impacts from natural gas, but it emits fewer pollutants than coal. And electric utilities are actually the largest investor in solar and wind in the United States. There's a lot of opportunity for growth there, and utilities are certainly taking advantage of it because as the technology is becoming less expensive, it's become more viable. And that gets to just one final point is, we spend a lot of time talking about disaster response, but all of the information that we collect and build is just as important for preparation and planning for systems. And that could be a whole separate panel. But that's just as critical to try to do some of this thinking on the front end rather than after something that's happened.
Great questions. I think let's thank our panelists one more time. And really what's occurred to me, I think that over the last several years, we've seen a lot of groundwork laid with ESIP's partnership with GEO, with the private sector, through the All Hazards Consortium, NASA's ongoing support, and all of these things coming together. And there was one more thing that I wanted to share. I asked Elise if you would just say one word. On the ESIP OGC collaboration, because this is an opportunity to fund work that would, I think, benefit.
Thank you, Erin. So, hi, my name is Luis Bermudez. I work at the OpenAQ Consortium OGC.
And we have a collaboration. We are a Type 5 ESIP member. We share similar vision principles of openness, collaboration, help improve how we share data, and for example, we have better solutions for disasters. We have previously collaborated in the GEOS pilot and the ESIP, an ESIP observer test bed. They went to our meeting to see how our process worked. The way that we do innovation, which is one of the main things that we have between ESIP and OGC, is by doing test beds, prototypes, agile solutions. And we're going to present what we did in testbed 12, which just finished, in these 2 sessions, one today at 4 p.m. and tomorrow at 4 p.m. And then testbed 13, which is going to be based on mass migration, models of social systems, and how we can better have open interfaces, open data, open solutions to better support utility companies, government, and others. So I invite you to go to these 2 sessions, or one of them, so you can learn about how to get funded and participate in our process and increase the collaboration that we have. Thank you, Erin. Thank you.
Great. So thank you for your patience as we ran just a little bit late, but and thank you for your attention through this session. Lunch is just right next door. And during lunch, at the end of lunch, we'll be recognizing some of our peers. So with that, thanks so much.